Check, 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 check. Check, 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 check. Checking the mic, checking the mic. Stream can't hear me, I'm checking the mic. Ba 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 ba. Checking the mic. Ba ba ba. Check check. Ba da da ba. Ba da ba 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 ba. Ba da ba 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 ba. Checking the mic. Checking the mic. Hey guys, how's it going? I'm finishing eating my burger. I'm finishing eating my burger. I'll talk in British when I'm finished eating my burger, okay? I don't know how to eat in British. Other than, like, not drinking water or something. I imagine that's what British people do, because they're European. Well, I guess British people aren't very European anymore. Hey-oh! Oh! Okay. Zing! Europors can't afford burgers? Oh yeah, burgers are so expensive because you have to pay a higher minimum wage. I don't even know what blood sausage is. I know that that's like the first thing you cook. If you're a dwarf in World of Warcraft, you make some blood sausages. So that's really all I know. All right, let me catch up on chat. I feel like my Twitch chat looks different. It's like denser, different font. Dude, I haven't been on Twitch in a hot minute. I've been watching like basically everyone on YouTube now because Twitch is unwatchable if you are not subbed to the channel. Which don't forget to subscribe in Twitch Prime for one content a year. When will we get a s'mores cam? Unfortunately, I didn't hook up the camera. Wait a minute. Oh no, technical difficulties. Technical difficulties. Everyone relax. It's fine. It's fine. Oh, thank God. I thought we were about to get waylanded or something. Woo! That could have been bad. Okay. Does the burger have perf? Not today. Not today. Unfortunately, they put condiments on my burger that I didn't want. And I'm pissed. Nice unreadable font, just like old times. Let me see if I remember how do you do the session thing in Vim? It's like session, save session. Oh my God, I have no idea. Are you streaming 444? No, there's no way to do that. Unless Twitch has added that recently. Is that a new thing? I X'd it out that they have 444. I didn't want to read anyways. It's fine. The code is about as readable as the Geek Pirates code. So we're role playing. Okay, we're getting in our low blows now, so we don't have to low blow later, okay? Okay, okay, we gotta put on a blind people font. Is this good? Is this good? Is this not big enough, or is like this what chat wants? Is this what chat wants? A bunch of boomers? So there's this thing I can use. There's a thing where you can make it so that like we're gonna try out using the like tabs or whatever they are in. Oh, I should count the number of times I do this. Oh no. Is this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. Okay. Okay. I don't have my readers on, thanks. Sick. Sick. Yeah, so today we're going to be working on an allocator. I also kind of want to see if I can connect to my LCR meter over the network. I haven't tried that yet. I'm curious what kind of interface it has. I'm hoping it has a good one, like my oscilloscope. I thought you were a machinist now? I am. I do many trades. But yeah, today we're going to be writing a single-threaded allocator, hopefully, and it's really going to be super simple. It's going to be a slab allocator. I don't think there's anything special I'm going to do with the allocator. I'm trying to think. I'm probably going to make the allocator do like, I really like the commit vec thing that I've made where I can like use the unused space of the allocator as a vector. So I can like push things and they're contiguous. So effectively, if I'm accumulating like one list, I don't have to worry about regrowing it and like reserving things. It only works for one thing per allocator, but it's kind of cool. I don't know. I'll get into that in a minute. Okay. Okay. Where's the camera? The camera is like 12 feet away. Nice, Morgus. There's a lot of unsafe in this code. We'll just go somewhere else. There you go. There's no unsafe here. You feel better now? Okay, I'm gonna try and plug this in blindly. I'm trying to feel out an Ethernet port. What's the most pluggable connector while not looking? Like blind, what's the easiest connector to plug in? Dude, why can't I find anything that feels like an Ethernet? Oh, it's already plugged in. X fucking D. Chat. XD. 3.5 is a good one. Yeah, I think 3.5 is fair. It can be a little hard to find. NEMA power? NEMA power is tricky because it's really hard to feel the orientation of NEMA power, I would say. Am I wrong? Because you have to feel like the two notches or determine it by the pins, which is kind of hard. MagSafe? MagSafe is fair. It's big though. That does give it an advantage. I would say that. I'd say that is an advantage. Okay. So, where is my I am plugged into LAN. What's my IP? If you're an IP chat, what would he be today? Oh, potential insecure, self-signed cert. Nope, not that. Okay. What about this one? That's also a self-signed cert. Okay, we got a lot of self-signed certs. Hey, I found it. Okay. Let's see. Chat, is this gonna have VNC? Connect? Uh-oh, something went wrong. Uh-oh. Insecure, is that FFmpeg? Oh my god, the drama's been so good. Do I need to like enable VNC? Is it not on by default? Device? Interfaces? Network? VNC on. Desired host name. Okay, we're in chat. We're in. Hey! Let's go! Look at that! Nice. I was wondering if this was going to have the same nice interface. And it does. I love this. And I should be able to click everything? Yeah, let's go. Let's go to super fast. Super fast mode. Oh, the VNC is not super fast. It's way faster on the device. We'll go to fast then. Maybe we'll go to medium. 10 a second? VNC can probably do that, right? Hog. I've been learning how to do AC, chat. AC is really hard, okay? So like with DC, everything's like really easy. And with AC, everything's like really hard and nothing works the way you expect. But yeah, I made probes for my LCR, so now I'm moving them close together. You can see the capacitance and impedance is going down. Now I'm moving them apart. Look at that. Isn't that crazy? How cool is that? Chat, who can tell me what the capacitance number is? What's the top number here? Tell me what that is. This is an SI prefix quiz. Nah, picofarad's not fair. You gotta tell me what this digit is. Here's, why do you stream like once a year? Twice a year is just a lot of work. Six what? 6 what? 6 exponents? It's not a 6 exponent. No, it's not 6, 7. Get the fuck out of here. We're not 5. 600 atto. Yeah, it's 600 attofarads. I can't believe how sensitive this instrument is. 6, 7. I'm surprised I know about 6, 7. I think I just barely do. Can I like do graphing on here? I think I can. Oops. Okay, move them together. Close, 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 close. Getting the probes real close. Getting the probes real close. Now I'm getting them far away. It's so sick. These units are tiny. Oh my god. A buff seagull. Thank you for the, I can't quite read that number. Chat, does anyone know what number? It's really far away. I can't read how many months Above Seagull has been subscribed. Is that 70 months? 68 months? It's really hard to tell. I don't have my glasses on. My 7-year-old son trolled a bunch of high schoolers when they stopped by trick-or-treating, telling them they could have less than 10 pieces of candy. When they counted it out loud and hit the cursed sequential digits, he yelled at them until they left. So toxic. So toxic. What are you teaching your kid? But thank you, Above Siegel, for the 69 months. Nice. Oh, should we be listening to music, chat? Desktop audio? My stream is like actually kind of set up. I kind of like didn't have to do anything. No webcam. Yeah, there's no place to put it. In both ways. I have no place to put it on the screen. And I have no place to put it physically on my desk. With my new monitor setup, because I went from 24s to 27s, I literally don't have any space on my desk for a camera. I'd have to like mount it to the ceiling and have a pole coming down. And the wireless feature of the camera randomly does or doesn't work depending on the firmware update. Dude, every time I stream with that fucking camera, I have to go like get a firmware update because they use some like stupid ass cloud shit. And it's like flipping a coin whether the current version will work with OBS or not. Because they like definitely do not correctly implement whatever protocol they're supposed to implement. Fabricate a webcam stand? I'm thinking about that. Same with a mic stand. Right now, I don't even have a mic stand. I just have the mic on the table. Right? So I can do that. It's, yeah, you're gonna hear a lot of key presses. But, yeah, I didn't want to put my microphone stand up because it sucks. Camera firmware and Rust development stream. Unfortunately, the issue is not the camera. It's actually the like camera monitor that can stream over Wi-Fi. So we'd have to do that firmware. And I don't think you guys want to do that. So, oh my god, the freezer project. The problem is I don't use that freezer anymore because the company that I used to have deliver frozen foods stopped delivering or went out of business or something. And so, like, now I don't need the freezer project. I think the next physical electronic project I want to do is a touch probe for my milling machine so I can determine if the tool is touching the part or not. Which I tried to do with DC, but the problem is the resistance is basically 0 when the tool is touching and also when the tool is not touching because the surface area or the cross-sectional area of the milling machine itself is so high that it just doesn't matter. Like, the resistance is basically 0 whether the tool is connected or not. But that's where I've discovered... Yes, I did have Schwann's. But, the magic is AC. That's the trick. AC allows me to measure the impedance, and the impedance is much, much more obvious when there's like a shorter path versus a longer path. Because the workpiece is always connected to basically everything in the mill. But with AC, I can kind of tell what's the shorter path. Rip their raspberry white chocolate scones. Trying to think if I had those. I think I did. I think maybe once. I've kind of had like everything on their menu once. Tesla's proud. Turns out that AC is like fucking magic, dude. But yeah, I had Schwann's growing up when I was a kid. I think it was like Midwestern at the start or something. And then it kind of expanded everywhere, and then they got private equitied, and they just couldn't do it, which is wild. Like, how can you have a frozen food delivery service that fails during COVID? I feel like you have to basically be stealing funds from the bank account for that to happen. Almost done with my burgie. Died after 72 years. I know, tragic. I think it was like family owned and like had pretty good reviews as a company. Yeah. Yeah. Whoop. Whoop. I love AC chat. Bad frozen food engineers, they might not have not used Rust. I'm so disappointed. I feel like chat's coming out with the Rust comments already. Rewrite it in Rust comments. Classic. Okay. Well, it's good to know that this LCR meter also has the nice interface. I think Roden Schwarz, like all of their equipment, I'm pretty sure they're using like the same OS for everything. So I think the usability is going to be the same on like everything, because I can now go to, yeah, check this out, chat, because I can also go to here, right, and here's my oscilloscope, and my oscilloscope has the same thing. Like, tell me this isn't sick, that I can just connect in and I can like use all the buttons and everything. It's I love it, chat. What happens to your own language? You mean slang? Will slang be memory safe? Yes, of course. I feel like memory safety just isn't that hard anymore. I think Rust has showed us the way that you should, if you're making a new language or writing a new browser, you should probably be doing it in a memory safe language. I assume these are cheap? Yeah, these are super cheap. But yeah, look at these beautiful waveforms. Look at that. Look at that. Oh. Oh, it's just what you want to see in a waveform. Beautiful. Beautiful. But yeah, friendship ended with DC. Now friends with AC. Okay. So, I gotta blow my nose, and I'll be right back. And I'm gonna get a water. And then, everyone, behave while I'm gone. Hi, S'mores. Who's a good boy? Who's a good boy? Come on, Bergie. There you go. There you go, Bubble. There you go, Bubble. Who's a good boy? Eat your Bergie. Yum, 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 yum. Yum, 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 yum. Yeah, who's a good boy? Good boy, is that good? Is that good? You like the Bergie? Yeah. Yeah. Okay. Okay. So, we'll get nice and cozy. Allocator for what? Today we're going to be writing an allocator for core, because core has existed for like 9 months, maybe longer. And I've yet to write an allocator that can free memory. Well, technically I have an allocator that can free, but it literally is Mmap. And when I want to allocate a bunch of 32-byte objects that end up being 4K, it turns out it's actually like really inefficient to do like 4K allocations when you don't need 4K. Free memory is wasted cycles, yeah. So yeah, what I want to do is I want to define an allocator trait. I think I'm going to do it basically the same Rust does, where you have a generic on vectors, and that generic is a reference to the allocator where that vector is allocated. And that's kind of my plan. This is going to be a general purpose allocator that's just meant for like quick hacking on code. It's not going to be turbo perf. It's not going to be designed for like really good fragmentation. It's just going to be a slab allocator, right? We're gonna bump alloc. We're gonna round to like the nearest power of 2. We're gonna bump alloc, and then when you free, we're gonna put it in a free list. And when you allocate, you're gonna check the free list before you actually bump if there's a existing entry. Super fucking simple. Yeah, it's not hard at all. Okay. Hello, SpaghettiOs. Okay. Okay, we're so back. Hell yeah, we are. That's because we're Mamma Mia! Mamma Mia! Okay, here we go. Here we go. Let's get some music going. We need to listen to some music. Otherwise, I'm gonna sing. I can't sing the whole stream. Ba-da-da-da-bow. Ba-da-da-bow-bow-bow-bow. Ba-da-da-da-bow-bow-bow-bow. Oh, I'm so torn, chat. Took my happy pills today? My happy pills are being here with you guys. Hi, Mr. Roboboto. ¿Cómo estás? Okay. Okay. Well. How loud is my music? I need to make sure it's not bleeding through my mic, and I don't think it is. I should probably... Let's see. It's silent? What do you mean? I think the music's fine. We're gonna go real quiet. Hope there will be a VOD. We'll see. Remember, we always censor our VODs if the stream doesn't go well, okay? How do I do the Vim tab window thingies? Vim... How... Tab new is Tabby, Tabe. That's the one. That's the one. That's the one. Tabe. Source alloc.rs. Whoa. Oh, I guess I have an alloc.rs, but that's not really what I want yet. How do you close a tab? Tab Q? Or is that gonna explode my computer and DD my drive? Code size check. Colon Q? Really? Oh, okay, okay. I thought for a second my computer was gonna blow up. Don't look, don't look at that. Oh, God. Don't look at that. Don't look at that. Don't look at that. Okay, You didn't see it. Nope, you didn't see anything. You didn't see anything. Is this what I want? No, I don't need plus stage 2. Just this. I close my eyes. Good. Good. Stay blind. Look at that, chat. You see that? You see that? Look at what runs in MIRI now. Look at this. I can do allocations in MIRI. How fucking cool is that? Why do you have a different keyboard? I got this keyboard like a year ago, okay? It's not a different keyboard. I've had this keyboard for a long time now. I think you're just not a true fan. True fans would know what my keyboard is. Still a different keyboard from the last time you streamed. Oh my god. Oh my god, you guys are toxic. This is why we don't stream anymore. Using default waybar is crazy. It's not default! This isn't default at all. No piling on me, okay, chat? Okay? Okay, what do we want to do for alloc? Core source. I don't even remember writing this much code, to be honest. I probably vibed this one out. Okay, what do we want for an allocator? I think, let me see where I do Mmaps. RG Mmap. RG : Mmap. I do Mmaps. Memory mapping files. Creating a stack on threads. In alloc, I do it twice. This is in shared memory. Wait. Alloc. Okay. I think we do all of the allocs in here. I think everything goes through alloc raw and dealloc raw. Yeah. Okay. So we need to make just kind of like a raw allocator that basically just takes a size and alignment. I think that's all we really care about. So, how do we want to make the trait for this? I kind of don't like alloc.rs. Is this even connected in? I bet it's not. Lib.rs, alloc. Because, yeah, I'm pretty sure no code is using this alloc stuff right now. Make build. Does it break the build to get rid of this alloc? Because, yeah, I'm pretty sure none of this stuff works right now. Yeah, this looks like vibed code, and you know what we want to do to vibe code? We want to delete it, because vibe code sucks. Okay, so, this is just basic, or allocator traits, and basic slab allocator. Perfect. And yeah, we will want syscall and probably pointer. So let's start with an allocation trait. I'm just gonna call it allocator because that's what Rust does. This is trait that defines interfaces for allocating and freeing raw chunks of bytes. That's how we want to describe it. And I think it's going to be basically the same as Rust, except for going to use rstate. So let's just do a... Oh, and we'll just say this is a const trait, because everything is const. We'll do a fn alloc size align, and it's going to return a mutable pointer. Size bytes with minimum alignment align. Align is asserted to be a power of 2. Okay, and then fn dealloc. This can be safe, right? Alloc can be safe. Dealloc cannot be safe, right? Right? Free size bytes from a pointer returned from alloc of the same allocator. And that one won't ever fail. So this will fail if it's out of memory, but dealloc is unsafe because they could just forge a pointer. So safety, the caller must make sure the pointer came from the same allocator that created the allocation itself, and the size matches the size provided to alloc, right? Right? Unless we want to like actually try and put guardrails on this, but I think to do that we'd have to do like closures and the like invariant lifetime tagging. Ultimately, this is going to be like really low level, so I think we're just going to stick with this. Okay. And we'll just start with this for now. I put guardrails on my Mmap allocator as pain in the ass. Yeah, I mean, it just, like, in reality, you're going to be doing kind of unsafe anyways, because anytime you're making an allocator, you're going to be, like, converting things to Rust references. So you're going to have so much unsafe already that I feel like the guardrails aren't really worth it. Okay. So the next thing we want to do is actually implement an allocator. So we'll do a super basic single-threaded bump allocator with per bucket free lists. And yeah, a super basic single-threaded bump allocator with per bucket free lists. And I think we have no intention right now of... We want to kind of design this to be as fast as possible. So we don't really want to worry about fragmentation or anything. Because solving fragmentation is just really hard. I feel like if fragmentation is a concern, you probably shouldn't be using a generic allocator. Like, my view is this allocator is just designed to, like, just work. Because right now, for the past 9 months, an Mmap and Mmap allocator has been fine. Because I am well aware that allocations have large overhead. And this is really just to decrease that overhead to make using dynamic allocations more viable in certain scenarios. So the one scenario, okay, so like the main reason that we're actually The main reason we're doing this is a specific access pattern that requires a lot of separate, like, parallel vectors that are accumulating. I'll get into that in a second. I'll read up on chat. How do you get different color for / comments? No idea. This is completely default Vim. Will Avad go to YouTube? Yeah. Okay, so basically for most things I've been doing, I've been using a commit vec, and I really like this commit vec API, right? So effectively, this commit vec is a vector. So right, we have a pointer to the actual storage. We have a length. We have an index. So length is the size of the allocation. Index is the current length of the vector. And what's really cool about this is effectively you pass in a vector that has capacity in it, right? So it has unused storage in the vector. This gets the unused portion of the vector. It sets that as the base and the length and index, and you're able to push to this, which means you're storing into the unused portion of the vector, and then once you're done, you call commit, you get a slice to that, and then the internal pointer advances. So effectively, it's like a slice bump allocator, right? So if you are, and it's super low cost, right? So effectively, this allows you to create contiguous dynamic length slices without any wasted storage, right? Literally to the byte, perfectly packed, and they're all sequential. So for a lot of things that you know you're going to access sequentially, it keeps everything very condensed, which is fantastic for like being on the prefetcher on the processor. The downside of this commit vector model, right, where you're only able to add to the end of something, you can't have multiple vectors being accumulated at the same time. So this works well if you're parsing a file or some protocol or creating a data structure where you're able to basically create an entire vector at one time, right? You're not doing other vectors at the same time, you're just doing one. Now, I've also made a commit vec set, which is the same thing, it's just multiple commit vecs, which allows you to have up to n concurrent vectors being kind of created. And this kind of manages like which one's currently active, so you're able to this will just pick a free one, and as long as you're using under n parallel streams, it still works. And this is kind of a hack to temporarily give me what I want with more of a generic allocator. The real problem is I've recently been working with a file format that defines, basically to parse the file format, I get a bunch of different like keys and values, and when I'm given a key value pair, I need to look up that key in a map and then append that value to a vector on that key. And ultimately it means that I'm like randomly visiting thousands of different vectors and appending to them in basically like random patterns. I could maybe get around that by like accumulating everything into one vector and then sorting it, but I think that's just way worse than having an allocator, right? So I've slightly improved that by adding, I added like another allocator of sorts, this mixed vec. Mixed vec basically has a fixed size representation up to n, and then beyond that it has dynamic representation. So if you have a data set where it's like most things have like 2 to 5 entries, and some things have many entries, then you can use this mixed vec where you can just set n at like kind of your median or like average element count, and then it will automatically switch to a dynamic representation. Basically, since my allocator right now uses Mmap, it allowed you to not use a 4K allocation if you had like a really small low n. The downside of a fixed representation, a fixed size vector, or basically array, is that now you're creating n, and if you have a map of these, now you have kind of a bunch of wasted storage, and you have a really sparse map, right? Because you end up, if you were to have n be really large, like 32 or something, and you're storing a u size as t, each entry in the map is massive because it has to hold this fixed representation for every single key, which is really annoying, right? So TLDR, I kind of have a couple different ways of hacking around not allocating, which is funny because it'd take like way less time to just write an allocator. So we're just gonna write an allocator, and then I'm probably gonna get rid of commit vec set, because commit vec set is kind of pointless if you have an allocator. And then I'm hoping that I can merge commit vec into the allocator, right? So like the hopes are that effectively the allocator can be like, you can effectively be pushing to the allocator and using the unallocated space prior to actually allocating, right? And then once someone allocates, or really, I don't know, I really like the model where, like, if you know you only have one active stream, then you don't have to, like, reserve storage, and then when you bump to a new size, you, like, copy all the vector elements or something. Instead, it's just like, yep, this vector just temporarily uses the entire allocator space, and then once you're done, call commit, and now you can do allocations normally again. But I think that might not quite work perfectly. I think I will probably keep the commit vec just because it's slightly more explicit. I don't know. I'm a little torn. I'm not 100% sold on how I want to do it yet. Hey T2SDE, thank you for the raid. How's it going? How's your stream? Sounds like what I'm dealing with right now. Been expanding my compiler to extract dynamic JSON schemas from data sources and later validate instance data against the schemas. Ooh. Nothing wrong with having multiple slabs for multiple streams. Yeah, I'm a big fan of having many allocators. So like, I'm pretty anti-global, and part of being anti-global means that effectively you're going to have to keep you're going to have to pass the allocator around with vectors that use that allocator, kind of. And my view is, like, I kind of have, like, I've been fine for like 9 months by just being creative with data structures and how I process things of using Mmap. And all I'm doing is I'm making it so creating the allocator is now the Mmap, right? Which is, like, I've been able to do Mmap for every allocation just fine so far. All we're gonna do is, yeah, now, like, basically before your hot loop, before your processing loop, you'll just create an allocator, and yeah, you're gonna pay an Mmap to create that allocator, but my view is, like, as long as you understand that creating an allocator is gonna do a syscall, you can pretty comfortably understand roughly the performance ramifications of that, and just know, move that allocator creation far enough away from your hot loop such that you amortize the cost of the syscall to the point of it not mattering, right? So I'm being extremely careful about no globals in this entire project. Right now, the only global I technically have is for standard out. I have a lock around standard out, which allows you to just not get mangled output when you're printing a bunch of stuff from a bunch of different threads. That's the only thing I have in a global, and I kind of don't like that. But I don't think there's a really good way around that, unfortunately. So, seems like sort of thing you could solve by having fixed size write back catch style buffer. where you read into n buckets of size m, each with a key you recently saw. When the bucket fills, you flush all entries. Yes, yeah. I know what you're talking about. So that was a design that I was thinking about. I never implemented it because it's like slightly complicated. And I don't know. I've been really struggling with fixed size, like const generics, where it's really hard to pick a good constant for a wide amount of, wide set of inputs. Where, like, for one file parsing, like 16 or 1024 or whatever, might be really good, but for another one, it might be, like, catastrophically bad, where you're effectively, like, never benefiting from the cache or whatever, because, like, the keys are too random or sparse, or there's more keys. Unfortunately, I'm just kind of dynamic pilled recently. I've been thinking about actually getting rid of a lot of my generics and const generics, even though that's like always been like a really big thing I've liked doing, because the code gen is, the code gen itself is usually a little better when you're using const generics, obviously, because you're getting like more specialized implementations, but then you end up where you can kind of never make small code, because almost every single thing you do ends up creating a monomorphized version of the code. It's tearing me apart. Like, it's even making me question how much I really care about having this, like, n for fixed size vectors, because basically anytime you use a fixed size vector, now you have a separate fucking implementation of vector, and it's just, I don't know. I'm hoping that what I can do is I can keep the fixed size vector around, but understand that I should only ever use it for like performance in a hot loop. But for all of my like standard library code, I should try to avoid it as much as I can. I don't know. I'm kind of torn. Okay. Okay, chat. Okay. Anyways, so basically, I need to support being able to accumulate to multiple vectors, and those vectors, when they grow too large, they need to reallocate, and that means they need to be able to free their previous allocation. The other way around this is to do the, I think Desu has been talking about it a decent amount in my Discord, where you can have a vector where instead of freeing the previous slice, right? Like, let's say you have a slice of 32 U8s to start, right? And you fill this up, and then once this is filled, then you go and you fill in this. And you can fill this up, right? And you can keep going. And effectively, this kind of vector, where you maintain these like power of 2 storages, this means you don't have to move things, right? So what's really convenient here is you don't need to copy when you grow your vector, right? And that's a really common issue with performance of like, yeah, it doesn't really matter in like the 32 or 64 case unless you're doing it a lot. But eventually you get into the problem of like, yeah, you have like a fucking 32 million entry thing, and this gets full, and you need to grow it, and now you need to do a 32 fucking meg mem copy just so you can keep using it again. So, yeah, I kind of like this model. The downside of this is that to make this work, I effectively would need to make sure that none of my APIs, does it depend if you have space after? No. So what this would basically be is like you have pointers, right? You have pointers to these, you alloc these come from like the dynamic allocator, right? So these are dynamically allocated, and then you have like null, null, null to the like max size power of 2, right? This is probably like 2 to the fucking 64, right? And effectively, when you outgrow your bucket, right, so once you hit 96 entries, you will then make a new U8 128, right? And then you can start filling this in. So these are not contiguous. And the downside of that, so the upside of this is you don't have to do copies when you grow things, which is really nice. I would actually argue that that is, it's tough. It's really tough. Because a pattern that I often will do is I'll like have a hot loop. I'll do like a vec is whatever, and then I'll do loop, and then I'll do vec.push where I'm like, this is my hot path, hot hoot loop, right? And I'm doing all my stuff, loop, the for file, right? I'm processing this vector. And then what's really cool is I can just do like vec.clear. And what this means is that the capacity for the vector will naturally converge to the size of the data set. And what it means is that you kind of never actually do reallocation, or like you never do copies. You do copies the first couple times you grow the vector, but eventually the vector kind of like learns, in air quotes, like learns the correct size for its use. So what's really neat about this pattern is like you don't have to know like really how long the vector is going to be for your file. It could be super different for different files or for different parsers, and it will just naturally kind of grow to the correct size. And since you're clearing it, you're basically you only pay the cost on regrowth, and you almost never regrow because the vector has already been used before in a previous iteration of the loop, right? So I really like this model. This is how I write most of my code. I think it's one of the most performant ways you can do stuff, because it really does learn, right? This effectively means that you converge to doing no allocations. You converge to doing no allocations, but you also don't have to know or predict ahead of time how big you want your allocator to be. So as long as you're processing like enough files or whatever you're processing, this just kind of automatically solves that problem. Isn't that kind of standard thing for how vectors grow? Yeah, they normally grow by like you double the size like every time you regrow. But what's interesting here, I would imagine that most Rust programmers would do this, right? Where you create a new vector, you do your shit, you accumulate to the vector, you throw your vector in the trash, which is going to require, like, let's say this grows to 1 million entries. This vector probably starts at like 32 or 16 or whatever entries. You're gonna end up reallocating and copying and freeing like 16 times every single time. So moving it outside is a really massive improvement to that performance. Yeah. Yep, just slap a vec clear at the start of the loop. Yeah. And because of this, this is a pattern you see like all over my code, right? This is a really common thing I do. This is also why like I haven't really cared about my allocations being Mmaps because of this. Because yeah, you pay an Mmap the first couple times, but if you're parsing a million different files, you do 2 or 3 Mmaps and then you're done Mmapping. Hey, Bubbo! Hey, Bubbo! What you see? What you see? Is he a friend outside? Let me check. Oh, there is a person walking in the cul-de-sac. Oh, good boy. S'mores, come here. S'mores, come here. Touch. Come here. Come here, Bubble. Yeah, I know. Strange danger. I know. Yeah. S'mores. I see him, Bobo. I see him. I see him. I see him. Come over here. Come and play. Come and play. I know, Bobo. I know. Smorg. S'mores. You are such a good guard dog. Yeah, who's a good boy? Who's a good boy? Who's protecting me from all the scary guys outside? Yeah, uh-huh. Hi. Hi. Have you been a good boy? Did you enjoy your burgers today? Yeah. Yeah, you like your burgers? Yeah. I know. I know, Bobo. It's okay. It's okay. It's okay, Bobo. Ah, Mr. Smorg. Mr. Smorg. Smorgies. Come here. Come here. Come here. Yeah. Look how much you protect me. Thank you. Thank you. Look at that. Who's a good boy? Who's a good boy? Yeah. Yeah. Who's a good boy? Who's a good boy? Who's a good boy? Who's a good boy, Bobo? Yeah. Yo, who's the best boy? Who's the best boy? You want a popsicle? You want me to give you a popsicle? Will that give you something fun to do? Or do you want a nap? What do you want to do? Nap or popsicle? Let's go get you a popsicle, okay? Come on. Where's your popsicle, Smurfs? Where is it? There it is. A good boy. A good boy. We're going peanut butter and beef. Butter and okay. Okay, who's a good boy? Who's a good boy? You are. Yeah, who's got a popsicle? Okay. Okay. All right. Yeah. So basically, I kind of like this Desu model. The downside is, so the biggest downside of this vector. So what's nice is you don't have to do copies, but copies can be alleviated by doing the vec clear pattern. Another downside is to use this API. Basically, I would need to make sure that like almost everything in my language, or everything in this core, takes an iter of t rather than a slice of t, because getting a contiguous slice is basically impossible, right? So I no longer would be able to get contiguous slices, which means I would have to make sure that like every single fucking thing takes an iterator, and like all the code that I write would have to be kind of aware of the fact that things are sparse. Now, interestingly, for syscalls like write and read, this data structure actually can just become a write v and read v, which is really cool. So in terms of doing like file I/O, you can do file I/O directly into this format, which is actually really cool. But you do have to do this iterator model for everything else, which kind of sucks. I don't know. I'm really scared of iterators in Rust. I think iterators notoriously have really bad code gen, so I kind of just always avoid iterators. I don't know. I'm torn, man. So, yeah. Iterator model sucks for hot loops with sparse backing. Well, what's interesting is that it's actually not horrible for performance because you're still doing sequential accesses. Yes, you have like gaps and breaks, but you're gonna be doing okay on the prefetcher. It's still obviously not as good as completely contiguous, but whatever. So we're gonna do the contiguous model. We're gonna have really good support for clears. So we're gonna make sure that our clear model has a really fast path, right? I thought the opposite for iter. Oh, interesting. Yeah, my issue is that I think LLVM really struggles. So effectively, iterators are a state machine, and state machines require storage in arbitrary locations. And storage in arbitrary locations means that you're reading and writing like indexes and lengths to memory. And if LLVM is unable to prove where all accesses of a given like iterator or state machine or chunk of memory happen, if it can't prove that it has knowledge of every single location, exactly how it's being used, it must actually omit the writes and reads. TLDR, if you use an iterator and your code is slightly too hard for LLVM to like solve symbolically in its optimizer, you're gonna end up with every single loop iteration effectively having a read and a write to memory, which now means you have like dependent loads and stores as part of your like hottest part of the loop. Which I think for most iterators it's okay, but it's really hard to know where that boundary is, and sometimes it depends on what you're doing inside the loop. And it's just spoopy. It's just spoopy, okay? It's just spoopy. Did you have to stream while I'm literally in the middle of moving homes? Yeah, that's why I did stream. Someone told me you were moving a house, so I streamed. Okay. That might always happen to LVM if you're unlucky to trigger it in a bad way. Type storage that iterator uses. I think I always forget how much type info Rust gives to LVM. Because there is like some loss, but I think there's enough type info there. It's just tricky. It's just tricky. I don't... Ultimately, I should try using iterators more and really pay attention to the code gen. But like notoriously, a great example was when you did like .iter like step by. For the longest time, step by could output some of the most egregiously bad code gen, where like literally it would literally like consume the iterator, so you'd have like the iterator in an outside loop, and then you'd have like a tight loop on the inside that's consuming from the range until the range mod n matches, and then you fire off the inside loop. Like, it's just scary. It's scary. It's scary. Okay, it's scary. It's scary. Okay. Anyways, let's go and implement this basic allocator. Okay? So struct basic alloc. Super basic single-threaded bump allocator with per bucket free list, okay? And this is gonna have storage, raw pointer to Mmap allocated memory, where where everything is stored, right? Then we're gonna have capacity. It's basically gonna be very similar to a vector. My experience with itters has been okay. If in doubt, use for each. Yeah, for each didn't exist when I started writing Rust. That was like added later. And so some of the problem is some of my biases and concerns come from a time before some convenience that improved those problems. More like Gambozo. That's fucking rude. That's rude. Size in bytes of storage. And then we're gonna do reserved. Size in bytes reserved at the virtual address of storage. This allows expanding storage in place up to this size. Basically, this is like commit memory, and this is reserved memory. Right. And I really like this model. And what I'm probably gonna do is when you create an allocator, what's actually really funny is this is what is this? This is who wants to get triggered? Press 1 if you want to get triggered. I think this is like XMS, and this is like XMX. Is this a thing, right? 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 Is that what it is? Is that what they are? XMS? XMX? XMS? And yeah, it is. Oh, let's go. Yeah. But yeah, that's actually a good model. Turns out the Java devs are actually like really smart, okay? All right, now we're gonna impl const allocator for basic alloc. Actually, we're gonna implement it for reference as a basic alloc. And we're going to make these simple allocator. Simple allocator, and we're gonna need in use. Number of current bump index into storage. Bytes. And then we're gonna need our free list as well. And these have to be all cells. So storage never changes, so that's constant. In use, needs to be able to change. Reserved never changes. So storage and reserved are permanent. Capacity and in use can change. So we'll make these. I think I still. Yeah. So we're gonna do atomic, and then we're gonna do mode cell. Okay. Okay, we're crushing it, chat. Look at that, our code builds. We just had one that Java people know what they're doing? I don't know, dude. You can't argue with, like, how good CS-wise Java is. I don't know. Java has, like, really good data structures. It has really good performance if you know how to write Java. Java's pretty impressive, okay? So... Atomic. Yeah, I think we're ready to cook, chat. We ready to cook? Ample basic alloc. And then we're gonna do pub const fn alloc. Or create new. Start reserved. Self. This creates a new allocation pool that can initially hold start bytes, but can be grown without moving up to reserved bytes. This is done effectively. Start is commit at the start, and we reserve reserved bytes of virtual memory at the address of storage, such that we can grow by committing new pages up to reserved bytes. Okay. What does mode cell? Cell just means that it's basically a single-threaded atomic. It allows us, it behaves the same as a cell, right? It's a cell usize, but in theory, if I were to do this, now the exact same code is thread safe, right? So it basically allows me to implement a thread safe and non-thread safe version at the same time, which is really convenient. So in fact, what I should be doing is I should be doing mode is this, right? And now I can do this. And now, now this is this allocator. We can make this work single-threaded and multi-threaded. What's our state? Our state is just a result. Okay. Yeah, I'm not 100% sure how I will do this to be thread safe. Thread safe might be a little hard here. I'm not 100% sure. Right, thread safety for a free list is... I think we can probably make this model thread safe. I haven't added thread support for MIRI yet. I don't really know how MIRI does threads. Can MIRI do clone or fork? Mmap. Let's see. It has pthread create, get set affinity, I think it does pthread. Yeah, it doesn't look like it has clone or fork. So it looks like MIRI uses libc pthreads for its threading, which is slightly different than my model, but we could maybe make it work. But TLDR, it'd be hard for us to test this until we added threading support. But we're gonna try. We're gonna try and implement this such that it works both single-threaded and multi-threaded if for some reason you were wanting to share an allocator between threads. I don't really think you would, to be honest. Basic alloc. Okay, new, this is gonna create a new self. So, the first thing that we need to do is reserved start reserved. Do I even like this? Like, do I even want the reserved storage? Yeah, I think I do. Yeah, I think I do. I don't like... I think this model is just kind of required if I want to support, like, really tiny programs that also theoretically scale to, like, really massive data structures without allocating way too much at the start. Unless I wanted to make it where I just create new storage, and then I would need to keep track, like I could keep like a linked list of the like heaps, and then it can grow indefinitely, right? Basically, like every time I run out of storage, I would then... I don't know. I like growing in place because then you don't throw away as much. I think it's just a faster model. I think I'm okay with this, okay? Okay, we're going to stick with this model. So, what we need to do is we need to add... we're going to do an Mmap. Basic alloc. Boom, boom. So we need to mmap up to reserved. Okay. And can we do this? Yeah, okay. CFN is going to take a start usize and a reserved usize. This is going to yield a mutable slice of bytes. Then we're going to have fn and cfn start usize reserved usize. This yields a mut u8. Okay. And then we're going to do this can fail. This one cannot fail, but it's okay. Let's just get the code working, okay? Okay, chat, let's get the code working. rs okay self. Then we're gonna have storage. We're gonna have in use is atomic new start. Atomic new 0. So nothing's in use at the start. Capacity. Whoops, what am I doing? Atomic usize mode. This. There we go. Capacity is atomic new start. And then reserved is reserved. Okay. So the first thing that we're going to do is we're going to assert that reserved is greater than or equal to start. Nonsensical reserved smaller than or reserved cannot be smaller than starting storage, right? So make sure the caller is sane. So reserved has to be greater than or equal to start, right? You have to be reserving greater than or equal to the same amount that you're starting with. That's good, so that constraint is satisfied. And we'll add that here. Must always be less than or equal to reserved, right? And we're actually gonna just say that. Start is less than or equal to reserved. Okay. Okay, how are we doing here now? Oh my fucking god. I don't know why builders have been so brutal here. Missing generics for this. Yep, let's just comment this out for now. Let's then go here. Const mode, and then we'll do mode. Dude, I have no idea why, like, when I get one Rust error, the entire fucking code base then fails to build now. I genuinely do not fucking understand it. It's so frustrating right now. It's been doing this for like a day. I gotta figure out what it is, but it's like the first thing is an actual error, and then everything else is just like the whole code base is just an error now. Okay, yeah, we don't have storage yet, and storage will be let. Storage is equal to RSC of const eval select of start reserved. CFN and CFN failed to allocate storage for basic alloc. Okay, and this is allocate the pool. And I think what we should do is also have, this should have the capacity should also be returned from this. This will be capacity. Right, so we'll return a tuple. Okay, let's get a tuple in here. Bam. So we're gonna call this, we're gonna get the storage, so a pointer, and then the size, which is the current capacity, which matches the size of the storage, and then the reserved amount is just the reserved amount. I guess a reference is just an enum of addresses? And a reference is just a pointer in Rust, basically. But it has a lifetime associated with it, which tracks how long the pointed to thing must be alive for. So it's really just tracking the lifetime, which is only at compile time. References in Rust and pointers are identical in the actual generated runtime code. Okay, whoa, hello world? It works. Okay, so let's do, let alloc is core alloc, basic alloc, new, 69, and 68. Okay, so this should fail, right? Son of a bitch! Cause, it wants the mode. Let's just make this by default mode cell. So by default, you'll get a thread specific one, which then means we have to do this syntax, because Rust is cringe. Okay, reserved cannot be smaller than starting storage. Our state was error. Perfect. So we're getting a nice Error message here telling us exactly what the problem is, that we can't have the reserved amount be larger. It should be able to be equal. And yep, now it's throwing an rstate error because we are trying to allocate and we haven't implemented it yet, so we're just throwing an exception there. So what we can do is, let's go and implement that. Mutable references have no alias. Yeah, that's fair. Okay, so CFN should be pretty easy. What we're actually going to do for CFN is we're going to do rsok, and then we're going to do const allocate. This. Super fucking easy. So we're going to allocate all storage. Let storage is equal to this. And do reserve at const time. So make sure to just use the entire pool always. Right, so when we're at const time, we're going to create the entire pool. It's going to be 4K aligned, which is going to match Mmap. That's going to be our maximum alignment for objects created from this allocator. And we're going to have storage here, which is the pointer that we just got. And then we're going to have the size, which is going to be reserved. Right. So that is the size of that storage. So now what we should be able to do is we should hopefully be able to do this at const time. All right, where we should be able to create this. Yeah, there we go. So println created allocator. I guess I can't print at const time. Yeah, I have an infinite loop in there because we can't print at const time. But we are able to create an allocator at const time, which is good. We'll keep that around, or we'll come back to that in a minute. But that should be good. I don't think const alloc can ever fail. Let me double check. At runtime returns a null pointer. Yeah, I don't think const allocate can fail. So we're gonna leave that. Okay, so there we go. We have this working for constant time. Now, the next thing that we're going to do is make it work at runtime, and at runtime, reserve up to reserved. Well, const means that we can write code that is evaluated at compile time. So we could potentially like write a program that does an allocation and a bunch of shit, and that will actually be evaluated at compile time, and none of that code will run at runtime. So it effectively means that we can like run our code at compile time, so we could write things that are just a little bit more ergonomic, which is really nice. Okay. But yeah, I'm a big fan of const. Like, I use it for one of my elf loaders. I load an elf off disk at const time, which means that I'm able to start my program with the in-memory representation of the elf without any code duplication, which is really cool. Like, obviously, it's more expensive at compile time. It takes a couple milliseconds, but it means I don't have to parse it at runtime, and it also means I don't have to, like, store the elf on disk with the program, so it also gets rid of a file dependency because the file gets baked in. I don't know. It's really cool. I love it. It's been really fun. Okay. Bytes with Mmap. So how do you reserve with Mmap? You just do prot none, right? Pretty sure that's how it works. Storage is equal to unsafe. Then we're gonna do syscall mmap core pointer null mute. Then we're gonna do reserved. Then we're gonna do syscall prot none. Syscall prot map private. Syscall map anonymous -10. And RSC from here failed to reserve storage with mmap for basic alloc, right? Failed to reserve storage. So if mmap fails, we throw that error. So bam, that will then give us storage. And then I don't think I actually have mprotect, chat. I haven't used mprotect yet. Can we use mprotect with MIRI? If mprotect, get that right, null. Looks like MIRI doesn't support mprotect. I don't think. I'm not seeing mprotect. Interesting. Interesting. Monkas. Monkas. Ooh. Is MIRI not gonna like this? Well, we'll try and do it with Mmap then. Reserved. I'm gonna have to do... Shit, how do we do this? Can we do this without mprotect, or do we have to specialize it for MIRI? How do we want to do this? I can't believe we can't do mprotect with MIRI. Okay. Okay, I think we're just gonna get rid of the reserved or the capacity model for now, because it looks like that's gonna be a pain in the ass with MIRI. And I really don't like having different code between MIRI and not MIRI, because that's gonna make it hard to test and evaluate. So, so let's just go and change this. Of the storage Okay. Can hold capacity bytes. Bam, bam, capacity. Bam, bam, capacity. Boop, 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 boop. Capacity. Ba, 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 ba. Okay. Which means this can go away. Which means this is just a pointer. Which means this is just this. Which is just this. Okay, and this is just this, and then that, and this, and this, and this, and this, and prot read or syscall. Prot write. Storage, basic alloc. Read write, private anonymous up to capacity. Okay, capacity. Okay, and then boop, 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 boop. And then this is capacity. Whew! Okay. Then it's just this easy, right? Mute C void. Yes. Dot cast into a U8 pointer. Perfect. Then this is gonna take 1024. Yay, we did it. We made a thing. Okay, so mmap at any address, create capacity, read, write, private, anonymous, not a file, no offset. So at const time, we create capacity with 4K alignment. Otherwise, at runtime, we do an mmap up to capacity. We call either one of these. Okay. And allocate the pool. And then in use starts at 0. And then we have a capacity. Nice. What's your take on drop versus defer? I'm not familiar with defer. I don't know what you mean. You mean like a garbage collector kind of defer type beat? No more SE Linux? Nah, it was too annoying. I run it on servers, but not here. It's just unusable with a GUI. Especially the MLS that I was running. Unfortunately, I liked it. It was really cool, but you know. Okay. So I think this is good. So this should work at const time, it works at MIRI time, and it works at runtime. Defer as in Zig Go? Yeah, I'm not familiar with Zig or Go. I don't write Zoomer languages. I write Boomer languages. Okay, so now we have to implement the allocator. Okay. Really, what I wish is that drop could return errors. That's really annoying to me that drop doesn't return errors. Unfortunately. The fact that drop, like, I don't know. Rust panics are just ass. TLDR. Panics are ass, dude. Okay. How would you handle an error in a drop impl? You'd have to have exceptions or like you'd have to have like a try operator sort of thing, where you can return an error. Rust, in theory, I think should be able to do it with results. Okay, so we're gonna do. So we need alloc. Okay. And we need dealloc. Do nothing. Smile. RST can't alloc. Perfect. So what you should be able to do is alloc.alloc 5, 8. Is it because I have to pull in the allocator trait? Use core alloc allocator. Oh, whoops. Whoopsie doodles. Whoopsie doodles. Self. What? Hello? What? Oh, wait. How did this even build? Oh, I get, it defaulted to cell. Okay. Is it because I need to make a reference? Yeah. Okay. So let's see. So it should be pretty easy, right, chat? Right, chat? We're going to let's see what I have for atomics here. I think I have compare exchange. Oh, I have try update. I have try update. Nice. 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 Okay, so what we can do is self.inUse.tryUpdate. This is passed in a context, which is something I pass in. Okay, a context. And then that gets passed back to me, context, and then val. And this returns an R state. Okay. Failed to allocate. Right. So I don't think I need the context, or yeah, I will. Rockin' 4K monitors? No, 1440p. Okay. Val is. We got a func, a mute C, we have a T, we return a T. So we want to do val. In this case, val is in use. And it passes that to me. Okay. Here we go, chat. Here we go, chat. We're going to do a thing where we pass in, for the context, we pass in the capacity. It's not mutable. Okay, so we pass in cap, no cap. Then we're gonna do let new in use is equal to in use plus plus so first thing we have to do, assert align is equal to 4096. Cannot use basic alloc for more than 4096 bytes alignment, right? Okay, so we have a 4K alignment restriction. So assert that the alignment is less than or equal to 4096. That now means that we can use the alignment of in use. So let's do context is equal to self capacity and size and align. Let's see what we can do here, chat. Let's see what we can do here. What's a ref to this closure? This closure gets a little toxic, okay? Just relax. Yeah, that's what I thought. So we actually have to do const fn closure. Relax, chat. Relax. Are you relaxed? Relax. Relax. Relax, chat. It's not a big deal. Like this. Like this. Okay, and then we do closure. Relax, chat. It's okay. It's okay. This is just how you do closures in Rust. Okay. Yeah, I don't like this. I want different music, chat. This music's scary. What's going on here? What's this bitching about? Mutable? Oh! Mute context. There it is. Do closures not work? No, closures work. Closures just don't work with const time in Rust. So this is what you have to do. You have to manually implement your closures in Rust. Okay. Now we're gonna have store and load semantics. I think both of these are relaxed here. Okay. Okay. Okay, I wanted 4 generic args. That's fine. I can just do that. Pretty sure that's what I want. Holy shit, our code builds. Holy shit, our code builds. Okay, try update build to allocate using bump allocation. So relaxed. I think relaxed is fine here. Cause yeah, we're not memory ordering shouldn't matter for this. Okay, capacity, size, align is equal to context. Right, so there we go. Now we can pass shit into the closure. Fucking toxic, right? Capacity, size, align. Capacity, size, align. Now, what we're gonna do is, we have to align it first. So, oh, we also have to do this. Assert that align.count1s is equal to 1. Alignment must be a power of 2. Right? So the alignment must be a power of 2. We can do that first. So alignment must be a power of 2. Alignment must be less than or equal to 4096. So now we've super constrained that down. Create context for closure. Pass that in. Now we have to align up in use to the nearest alignment boundary, and we can safely do this by doing aligned is equal to in use u plus size u minus, or sorry, no, align u minus 1 and align mask is equal to e align u minus 1. So subtract 1. So that's an unsafe subtraction. Subtract 1 from the alignment, which gives us the mask. Add the align mask, and then and with align mask, right? So this is round in use up to the nearest align boundary. Is that correct? Size explicit size on that. So take the alignment, subtract 1. That gives us a mask. Add that mask. And not mask. Yes. You are right. You are right. Okay, so plus, so this is align mask minus 1, so 4 becomes 3, plus 3, and not 3. Yes, this will align it up to the nearest boundary. Okay, now, add size to get the new in use. Let new in use is equal to e. Actually, can this be unsafe? I don't think I can do this. This one. Can that overflow? Yes, it can. Okay, so this cannot be unsafe. So this has to be checked, because this could overflow. So we check for overflow there. So here, there can never be an underflow. We can never underflow subtracting 1 because 1 bit is set. So since 1 bit is set, this is always okay, so we can do unchecked math here. Here we have to do checked math because adding this alignment mask, in theory, could overflow in use. If we're at -1 and we add 3, we would overflow, so we need to check for overflow there. And then here we also have to check for overflow, so we're going to do aligned plus size. Okay, and then we need to assert that the new in use is less than or equal to capacity. And this will be out of storage in basic alloc. And this is make sure we fit in the allocator, right? So if the new in use is less than or equal to the capacity of the allocator, so assert that, otherwise we're out of space. And at this point, we have a valid allocation at aligned for size bytes with alignment. And we need to bump in use to new in use, right? So we're going to return from this RSOK. The closure returns the value we want to update in use to, which is going to be new in use. All right. So that works. Then what we need to do is we need to have an output here, which is this is going to be the output from this closure. And ref mute output, right? So then we'll do output is equal to aligned, right? And that's the location offset to newly allocated storage, right? So what I should be able to do is attempt to reserve storage. Allocation was successful. Return pointer to storage. And this is now going to be self dot, what do I call it? Storage. Add. To that pointer, we're going to add context dot 0, 1, 2, 3. Now this is a mutable pointer, and this is RSOK. So we return a mutable pointer to the location in memory of aligned, right? Thoughts? Thoughts? To Elka's U size colon X. Yeah, okay, let's do another. And we requested 8-byte alignment, so this should be at 8. Yeah, let's go, baby! Let's do a 4-byte with 8. Yeah. Perfect. If we did 5, we should now be allocated at 8. Yes. If we do a 3, we should be allocated at 4. 0 will be allocated at 0. Do I want that logic? But I think this is looking pretty good. Alignment must be a power of 2. Must be less than or equal to 4K. capacity size align, output. Capacity size line from the context. Subtract 1, which is always guaranteed to be okay. Do checked arithmetic to add to the current in use. Add the alignment. Mask. Add align mask, which is correct. Then and not align mask, that's rounded up. Add the size from that aligned amount, which is the new in use. Make sure that is less than or equal to the capacity. And then set the output, set the new in use as the actual thing. Try and update that. Relaxed is okay here because we're not sharing this memory between threads yet. That would happen through another data structure where you actually like share the reference. So relaxed is fine here. We just need this update to be atomic. Pass in the context the closure. So we're updating in use to new in use. If and only if all of this can be satisfied. So we have to be able to allocate the aligned thing. In which case, yeah, get the base pointer and add the offset. Show an error message on overflow. I think this, right? There you go. Out of storage. Or I guess that's not overflow. We gotta do this. This will overflow? Yes. Right. So integer overflow on add. That is on line 1058. Well, it's on line 88 in here. So this overflows. Align plus size overflows. Yep. Yeah, chat, you like this error message? Isn't that nice? Isn't it beautiful? Tell me that's not the best error message ever. Oh, it's just beautiful. It's just beautiful. It's pretty good, not gonna lie. Yeah, I know. Yeah. And you get the exact same error message regardless of optimization level, which is really nice. None of this shit gets like deleted because of inlining. This is always get the same thing regardless of optimizations. I love it. Okay, so now we have allocations. Now we gotta make a free list. Okay, allocated. 4. Yep, and then let's try a 3 with a 1. This should be at 3. Perfect, yeah. It's working exactly as I intended. The only unsafe thing we're doing is just this subtraction, right? Is that the only unsafe in this whole code? Is, obviously that allocation, the call to mmap, that subtraction, and then the addition to storage, but that is safe because new in use is less than or equal to capacity, which means that this cannot overflow when doing the pointer arithmetic. Do you do that with a thread local error stack? I'm actually not using a thread local error stack anymore. That's actually all stored in this. The thread local error stack was having really bad code gen, especially when you like discarded it. So it's actually fully contained in here. There's just an array in here that contains like fixed for like 16 entries or something on the stack. Ultimately, if you never are observing that stack, it all kind of goes away. But yeah, it's kind of a toss-up. Sometimes the code gen is bad, sometimes it's good. I found that thread local storage was kind of worse in general. And this is easier because you don't have to worry about like recursive stuff in our state that does our state. Error messages must be static strings, yes. Yep, I'm fine with that. That's how I've kind of always done it. Because I can create error messages at const time, right? So I could theoretically like use a format string for one of these. So I could do like rst format a const string, and I could say like foopy, and then I could say like apples, something like this sort of thing. It's a little complicated because it's hard to like pass things in, but this could in theory be like something I stringify or something like the stringify foob. I think that will work in this case. Yeah. So like I can do format strings, but it's hard to pass stuff into const. You could really only use this to like use like for mode. I could probably do it for maybe. I forget how it works. That might be too literal. It's slightly complicated, but yeah, I can do like some formatting depending on the. Const generics are still like really hacky in Rust, so it's like sometimes hard to pass them in. I use that in a couple places. It's kind of nice. But I don't use it as much as I should. IMHO. Okay, so next thing I want to do is a free list, right? Because the whole point of this is to be able to free. This is really easy. What about deep call stacks? Yeah, I just truncate, because it just doesn't really matter. My view is like, if you can't find it in the first like 16 things, just temporarily increase the limit. Or write your code way fucking better, because why are you nesting that deep? like at the end of the day, I think the issue is usually going to be closer to its target, but yeah, I can also turn off the whole thing where it doesn't store the strings for like binary size, or if I like want a release build that doesn't have all the info, or I could like turn off source line but only keep messages, yada yada. So there's like, I don't know, it's pretty tunable. Ultimately, if I turn off the error messages, our state is literally just an option where it's like some value, and then otherwise it just encodes that it's an error, but it doesn't encode any information about the error, so it has like no stack, no storage. I find it works pretty good. Yeah. That's something I want to be like more first class in my language, but I've always done it as thread locals. The problem is it's really hard for the compiler to reason about the thread local. Like, effectively, reads and writes to thread locals are always going to be flushed, which means that even if you discard the error or like never unwrap the error, the compiler is still going to like do all the stack writes or all the TLS writes, whereas when you have it is like an owned stack reference. TLDR, LLVM really only likes optimizing out shit if it's on the stack. If you're writing to a global or a thread local, which is just a global with magic sugar, LLVM is going to basically always issue memory reads and writes at the starts and ends of things that are using it. And there's kind of no way to ever get it to stop doing it. So, it sucks. But it's also a really hard problem, right? I think the issue is like C and C++, where there's kind of like any pointer can point anywhere. Whereas I probably would switch to a like, instead of using pointers, having like a pool reference and an offset in that pool that allows you to have better knowledge about like whether or not you can omit writing to something, because when you write to a global, it has to assume other threads could observe that global, right? And when you read from a pointer where it doesn't know exactly the provenance of that pointer, LLVM just has to assume it could be pointing to literally fucking anything, and thus it could be reading anything. And it just is so wide open. It's why, like, it's the same reason I'm scared of iterators, because iterators kind of naturally store their state in memory. And if for some reason LVM isn't able to observe like the entire memory dependency chain for the storage, it has to assume it has to flush it and reread it on those boundaries where it can't reason about it. So, yeah, it's tricky. This version, LLVM can only optimize with inlining. Yeah, if it doesn't inline, it has to write out the whole stack. Yes. Yeah. That being said, my view is like, I never write code that throws errors. Like, to me, R state is meant to be fatal. It's meant to be a replacement to, meant to be a replacement for panics, basically, and kind of results. It's like, basically your program can't continue. Now, obviously you can discard an R state error actually quite easily. But my view is that errors are very rare, so you only pay that cost on error. Like, the parent functions are going to have to allocate room on their stack to receive the R state stack, right? That's what's going to happen. It's going to sub their stack to have enough room for this, which, keep in mind, is going to be like 16 pointers. So you're going to allocate room for like 64 or 128 bytes, but you're not actually going to write it or memcopy or use that storage. You're just subbing 128 from the stack until there's an error. And my view is like, it doesn't really matter. Like, you're kind of only paying that cost on an error. And thus, I would rather LLVM be able to reason about it during inlining versus kind of always having to like flush out the R state to some extent to TLS. And TLS is a problem because recursion. TLS doesn't allow you to have like you can't be accumulating two R state stacks, right? You can only have one stack being created at a time. Whereas this allows you to have an infinite amount of stacks, which is pretty convenient. I have maybe uninit in there. Is it Paramore in the background? Yeah. Yeah, I forget how it actually is. Tabe, R states. I think I just have a vector in here. I have a stack. Stack might be a vector. Yeah, it's a, yeah, this is what it is. It's a vec. So this will have an in use, which will be set to 0. And then a capacity, or it won't have a capacity. The capacity is just hard coded as 8 because it's fixed size stack. So this will require writing a 0 to 0 out this stack. But you only have to write in that 0 when you return an error, right? Because it's on an enum, right? So this stack doesn't exist at all, aka it's completely uninit until you create an error in the first place. And then, yeah, if errors are censored, then this is just empty. So, I don't know. TLDR, my view is like, unless you are expecting thousands of errors per second, I think the owned version is better than a TLS version. Ultimately, if I have something that's like expected to return an error, my view is like that's not really R state anymore. My view is R state is like fatal or things you don't expect to ever really to handle. Maybe you handle them in very weird edge cases, or like you handle an error when processing a file, like invalid header, and then you continue to the next one. But I think it's plenty performant. Wouldn't that mean R state is always returned on the stack? Yes. Yes. Which is what I want, because LLVM can reason about the stack way better than about a global. Okay, so try to reserve storage. Perfect. So then what we actually want to do is we want to do buckets for sizes. And what buckets do I want to do here for slabs? I think we're gonna probably do buckets up to maybe like 8 megs. Powers of 2 from probably 8. 8 to 8 megs. Need some sleep. Good night. Yeah, good night. Hmm. Oh, what do we want to do here, chat? I think we're gonna probably do just a straight Mmap over 8 megs, because there's almost never a reason to have massive allocations like that in a pool like this. So I think we'll fall back to raw Mmap for massive allocations. And then, yeah, how big is numbat log 2 8 megs? This should be 23. Yep. And then 8 is going to be 3. Yeah, so 20 bits. 20 bits. 20 bits. So we'd have 20 buckets. Do I like that? How expensive do I think an Mmap is? Probably not too bad. Probably go to 1 meg. I mean, I guess number of buckets doesn't matter too much. And minimum size of 8, I think is good. Okay. So I want to do like a pretty dense free list. I think I'm going to do a linked list of arrays. I'm not 100% sure how I want to do this yet for the free list. What are your thoughts, chat? Chattanooga. Free list. Free list. This for the purpose of mirroring core? It doesn't really matter. I want to support MIRI with this allocator model, but it doesn't really matter. I think this is actually not great for MIRI because I don't think MIRI will understand what the individual allocations are. I think it would if I explicitly call like an alloc aligned libc API. Yeah, this is just alloc. Yeah, I could call like aligned alloc in libc, which would probably want to be the best way to do it for making sure that MIRI is fully aware of it, but I also want to be able to test the allocator design itself with MIRI, so I don't want to also have MIRI be different. It's tricky. So, free list is atomic Um. Hmm. Hmm. We're gonna have 20 of these, and I'll be storing mutable U8. Free list for each POW2 size? Yeah, yeah. Pretty classic design. Pretty cheap. Okay. Um. Hmm. Pointers to how do I want to store these? Because I think I want it to be a linked list of arrays where there will have to be an atomic length at the start of the array. Um. Hmm. Hmm. Can I do this thread safe? Like, I'm trying to think if I can. I know I can do a linked list thread safe. But can I do an array thread safe? I feel like I've done linked list of pointers, but I can't remember if I popped. Yeah, I think what I did before is I would have per thread free lists. Or I would atomically add things to the vector, but then I would pop the entire vector upon alloc into a thread local free list. What I think I did. And then basically, like, you get the entire array of pointers when you pop. I forget what I did. Because linked lists are usually really bad here. Honestly, I just don't know when I would ever want to share an allocator between threads. Like, that uses pointers, right? If I'm using indices, I can see why I'd do it. But I think we're just gonna make this single-threaded. I legitimately don't see where I would ever use an allocator like this across threads. Which then makes this a lot easier. I think this closure will optimize well. It means your box and vec aren't move, or you mean they're not send. I mean, I don't use send. I don't think I ever would use send. I think I just don't really care. Let's see. How would I want to do this? How would I want to do this? Do I care if this is sync? Like, do I want this to be a threaded allocator? And I think no. Unless I can make it threadable with like basically the same design. Otherwise, I'd rather have a separate allocator that's just designed for threads. Because you need a fast path allocator. You need a non-fucking slow-ass allocator. But I'm pretty sure that I've done a shared allocator pool like this atomically. Or at least pretty damn good. You can do it with a linked list. Let's just let's just do the linked list model for now. A super simple linked list model that is thread safe. Pointers to linked list of free entries for each 8 to 8 megabyte log2 bucket. Null indicates end of list. Right, so then we'll have a free list. Oh god. Is this one of the things that's hard to do in an array? Slice, where are my arrays? From FN? Yeah, this sucks. Yeah, just gotta manually do this one. Fuck. Um. Pointers copy? I think they are. Let's see what happens. Yeah, that's okay, because they are copy, because they're pointers in this case. Okay. Okay, and then this needs to be atomic. The problem is I don't have atomic yet for pointers. All right. My atomics must be integers. Fuck. How does Rust do atomic pointer? Okay, yeah, they're kind of special. Hmm. Hmm. Oh. Hmm. Hmm. Yeah, how is this done? Oops. Tab. Hmm. Yeah, I need to add atomic. I need to add support for pointers for my atomics. To do this, oh my. I think Rust just does copy for these, right? Let's see. Yeah, Rust just has a T copy requirement. I want. Let's see. What else do? Pretty sure I can just do like integer or pointer. And I just have to do corp source marker, which is I think pointy sized. It's actually now in my libc. Is it just sized? I think it might just be sized. All right, we're gonna give it a whirl. We'll give it a whirl. We'll give it a try. Good old college try. Yeah. Great, atomic type. Make that unsafe. Unsafe impl t integer. Atomic type for t. Okay, so all these constraints are now going to become atomic type. Atomic type. Can't wait to have some MIRI bugs here. This will be fun. Fuck. Looks good. Okay. Yep. Woo! Okay, and then let's make this have a copy constraint. Okay. Now we have to make our intrinsics also use this. So pub types which can be used for atomic. What language is this? This is Rust. Okay. Atomic type. Atomic type. Atomic type. Integer not implemented. That's for the intrinsics. So we're gonna do atomic type. 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 Okay, we're getting there. Okay. Integer. Fuck else is there an integer constraint? Oh, here. Yep, because it's only implemented for that. So then what I'm gonna do is I'm gonna do for mutable references of t. For integer types, for mut t. So I'm being extra strict. about what pointers I'm allowing here, just for funsies. The submemory allocator? Yeah, we're working on an allocator. Right now we're working on atomics. Why so? Because I feel like it, because it's really just sized, right? Is it sized? No. Is it just this? What's the... Does pointers... I forget how the new sized stuff works. Yeah. Rust sized hierarchy. Yeah, I just don't remember how to check for a fat pointer with the new shit. Because this stuff has been changing a lot. I think I'm just fine with this. Right. Just require sized here, technically. If we want to be super explicit. Okay. Right. Atomic type. So integers are atomic, and mutable pointers to t are atomic. And atomic type requires copy and size. So we're just trying to be like extra strict here to not have a foot gun. Yeah, I just don't know if we can do all of this generically. Copy isn't implemented for that. Yeah. Right. I'm not supposed to have copy on atomics, I don't think. Nope. Okay. So that's fine. We'll figure that out. Oh yeah, we can do a const block. I forgot about that. I forgot you can. That's the magic trick now. Atomic new null const. Yeah, that's the magic trick. Okay, wrapping add 127. That's on atomic. So now the issue is having all of these. I guess I just need to implement wrapping add. And equality. Okay, that shouldn't be too hard. So I'm actually gonna do that on these. So we're gonna do pub const fn wrapping add, which is gonna take a self and an other and produce a t. And then this will be wrapping add self.wrapping add other, right? Because I need to, Dude, I have no idea why it's doing this. I don't know. Oops. Okay. Oh, yep. This is const trait fn impl const bam. Okay. Oops. Self to self. That'll do. Self. Nice. Then we do the same thing here. I don't think I have wrapping add yet on pointers. Yet. And then we have to do equality as well. Do I have partial EQ on pointer? Is that a thing? It's tricky because at const time a lot of this stuff doesn't work. Yes, but I should have partial EQ for those. So we'll add partial EQ as a requirement. That should just solve that, right? Can I do that here? I don't think so. I think I have to do that with a where clause. Pretty sure I have to do that with a where clause. Okay, const. This has to be hard const, I think. Partial EQs not implemented for mute t. I think I've just not done that yet. I guess I just don't have it for mute. Can I do mute? I think you can, right? Why couldn't you? Yeah. Yeah. It's just the same thing. Mute. There we go. Okay, we're getting there. Okay, so next thing we have to do is 39. This is gonna be a hard const requirement on atomic type, and I think that works here. Trait bound const. Oh. Yup. Please let me do that. Please. No! Fuck. This is what I expected. Okay. I think I have a const partial EQ, which I think I can use. Const partial. Yup. T. Let's see. Let's go for it. Oh. Come on. Give it to me. Give it to me. Let's maybe go. Please, 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 please. T. Oh! Oh my god. I can't believe it. I can't fucking believe it. I didn't even know I had wrapping add. Where's my wrapping add for pointers? What? Where's that even coming from? What? What? Oh, it's recursing. Okay, yep, that makes sense. I was about to say, I'm pretty sure I don't have wrapping add on pointers. Okay, let's go get that. Wrapping add on pointers, which uses wrapping offset, which does arith offset. Which I don't have. Doing pointers is very hard. Unfortunately. At Const time, pointers are like a complete pain in the ass. Wrapping offset, so we gotta make sure that we're doing all of these correctly with intrinsics. Looks like they use arith offset. So they do wrapping add, which takes a U size, which then does a wrapping offset, so we're just gonna implement it the same way. Add an unsigned offset to a pointer using wrapping arithmetic. This is pub const fn wrapping add self counts usize self where t is sized. Then we do self wrapping offset, which is just unsaved crate intrinsics Wrapping offset is arith offset of self, count as I size. Okay. So we gotta go grab that. Gotta go grab this. Okay, and arith offset. Okay. It's a new pointer from an offset using wrapping arithmetic. That only with const? Is there an arith offset mute? Or do I have to convert to mute here? Wrapping add on mute does wrapping offset on mute. Yep, it just casts it. Okay. Okay. I trust you, Rust. So still recursion, that makes sense because we have to implement it for mute t. Boop. And now this will fail to build, yep, because it's like, I want the thing. And then we're just gonna do an as mute t, or as mute t. Bam, bam, thank you, ma'am. Beautiful. Wrapping add. Oh, I don't even want wrapping add. I want... No, I do want wrapping add. Alloc type. Ultimately, I think add will add a U size. Right? That's what they do for atomic U size, I think. Atomic U size is... atomic pointer, they use a fetch pointer add, which does a U size. Okay, that's what I thought. So what we're gonna do is we're gonna do type add RHS is add RHS, and then this is gonna take self add RHS. And then type add RHS is equal to self. Right. All right. $146, which is this. Yes. Come on, you bitch. Come on, you bitch. Oh, we're so close, chat. We're so close. We're so close. Val, 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 val. 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 Pointer. Val. Yup. Yup, 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 yup. Yes. Come on. Okay, okay, okay. Okay. Let's go! Let's fucking go! Let's go! Woo! Okay, I think we now have support for pointers in atomics. My bumhole. Which means we have a free list. Okay. I think we're cooking, chat. I think we're cooking. Hi, Smorbus. Smorbus, I'm gonna need to towel you off. I'm gonna take a quick towel off s'mores break. You're all wet. You're all wet, bum, you know. Hi, bummus. You having fun? Come on in, boo-boo. Come on in. Water is fine. Mr. S'mores is Mr. S'mores. Come on in, Mr. S'mores. No, you are soaked. You are soaked. Orbis. The Smorbies. Oh, Mr. Arby S'mores. Hi, RB Tree. Mr. S'mores, you are so wet. You are so wet. You like getting toweled off, Smorgy? You like getting toweled off? You like getting toweled off? Who's a good boy? Who's a good boy? Who's the bestest boy in the whole wide world? Mr. Smorgas! Mr. Smorgas! Who's a good boy? Who's a good boy? Who's all wet? Who's all fluffy? Who's all wet and fluffy? Mr. Smorbo is. Mr. Smongo. Oh, who's a good boy? Who's a good boy? There you go. There you go, Mr. Towel. Towel. Yeah? No, I'm talking about you. Oh, boy. good boy. You're a good boy. You're a good boy. You're the best fucking boy in the world. You're the best boy. Who's your best boy? Yeah. Who's your good boy? Who's your good boy? Who's your best boy? Yeah. You're a good boy. You're a good boy. Android. Mr. Moses, Moses, Mr. Moses, Mr. Moses, Mr. Moses. I'll play with you in a bit. I'm sorry I'm streaming. I know you're gonna have to go to your place, so I don't shock you, Mr. S'mores. That's a reference. I don't actually shock him. He's a good boy. Okay, what'd I miss? Holy shit, I got raided. I got raided while AFK. Yeah, my dog was outside. He got all wet. It was pouring rain, so he was soaked. And then he came in, and I had to feed him his meds. And of course, he spat it out like 10 times, so I had to keep giving him jerky until he finally took the medicine. It was also muted. Classic. Classic. Thanks for the raid. Okay. Man. S'mores is such a good boy. Okay, so what did we do? We just made atomic pointers. In theory, we just implemented atomic pointers. And we're going to be doing compare and swap on them. We're going to be doing compare exchange. Oh, the scary thing about compare exchange is I don't think we can do it at Const time. Right? Because I have to do pointer equality. And I don't think I can do pointer equality at Const time. Let me see if there's any way to do that. Oh, wait, no, there is a thing for it. What is it? There is a way. I think I've done it. Is it? I'm pretty, pointer guaranteed compare. This. Which I think is what I need to do to make this allocator work at Const time. You like how hard everything is when you're trying to make a unified implementation for single thread, multi-thread, and Const time and all combinations of those? Const is so scuffed in Rust. It's tragic. It's so bolted on. Unfortunate. But I think we're gonna make some good progress here. So we're gonna need to be able to do just pointer equality, I think, is the only thing we have to do. Or they just like RustCon. Yeah, it's just hacked in IMHO. I don't really know what I'd do differently, to be honest. I haven't thought about it too much. Okay. Null indicates end of list. So here we go. We start with an empty free list, which is correct. We perform allocations. Then we free allocations. Pointer size. That's why people shill functional programming. Yeah, I think that's fair. Okay, so now what we need to do is we need to implement a function that creates the allocation size. So round up a size to the actual size to allocate, such that it matches a free list bucket size. Yeah, message passing sucks, IMO. Just not how computers work. Unless you got raw cache coherency bus. That would be really cool. Message passing, but it's like hardware accelerated on the cache coherency bus. Be sick. I don't even know if that would work, to be honest. Haven't thought about it. Get size. Const fn get size. Use size returns a use size. And how does this work? Oh, we also have to force alignment, don't we? To do free list. And thus taking an alignment is kind of pointless to the allocator. Or more specifically, we'll probably assert the alignment is matches something. I think alignment will be 16 or 8. See. Yeah, this is hard. Yeah, I'm still not sure what I want to do for alignment yet. Do I even want an 8 bucket if we do 16 alignment? Because that wouldn't make sense unless I want to do get size align. So we have to get the okay. So Rust has a next power of 2, but I forget what. I think they just implement it. What do they do? No intrinsic for it. While power is less than size. Yeah. Yeah, I always forget this one. But yeah, Rust has an x power of 2. One less than the next power of 2. Ah, yeah, that makes sense to do the one less than. Self minus 1. Maybe. I think I'm just gonna steal that. Because it looks good. And that one's hardware accelerated. Okay, so let's go to source integer. Okay. Self. I don't think I'm going to be able to do math here. Convert. Self is integer. I do have self 1, self 0, self 1. And this is unchecked is correct here due to this. If it's less than or equal to 1, so we can safely do that. What's this bitching about? Dude, I don't know why my errors are fucking so bad in Rust right now. I feel like this is like a new thing. I recently updated Rust. I don't know what's going on. Okay. So, dude, I don't understand it. It's like the entire code base cannot build if one thing cannot build. It's really weird. Do I already have this? Okay. Okay. Zeros. Where is it? Here we go. That's what I wanted. Okay, this is count leading zeros, but returns undefined if x is 0. Okay. Okay. Oh, nice. That just builds. So then we do this. Hopefully this shift works. Nope, because that's not a self. As should be able to lossy cast this. Right? Where self is const integer. Okay. EZ. Next power of 2, self yield self. Where self const integer. And then we'll do self 1 less than next power of 2 self plus 1 e. Because that can fail. Get the next power of 2 for good. Bam! Okay. Okay. Relax. It's not over. Oh, is it colons? Do I not support colons in my E macro? I don't know if I've used colons in there. Is that the problem? Ooh, we don't have integer promotion. Oh no. Who's the band? This is first to 11. Oh my god. Oh. That should work, right? Well, I guess we just don't want a super add. Let's just do checked add self 1. Yeah, super add isn't gonna work in this inside of integer itself. And is my checked add R state or option? Option. Integer overflow on next power of 2. Boop. And scoop, boop, boop. One less val checked add self. Uh-oh. 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 Oh, no. Oh, no. It's a fucking disaster, chat. We're in const hell. We are in const hell. What do you want? Is it the checked add? No. Oh God. Oh. Oh. What the fuck? This fucking language, dude. This fucking language. Okay. I think we're cooking. It seems like a compiler bug. Yeah, well, welcome to fucking custom core. Yeah, if I break the build, like, can I get... Nah, like, sometimes the errors are fine, sometimes they're not. Okay. Did we do it? Did we do it? Did we do it? Next, power of 2. If size is greater than 8 megs, else, actually if it's equal, otherwise size, we're gonna do size 8. What switches are these? No idea. Size next power of 2. Ah? 8. Next power of 2, 16. Size 16. Nah, they're not cherries. I have no idea what they are. They're Keychron. They might be Keychron yellows? Bananas? Bananas? Mints? Are they minty? I think they're mints. I have no idea. take one key out and see the color? That's ableist. Let's not be toxic in chat, okay? No ableism in chat. Now I need like an unwrap unchecked on this. Or an unchecked version of this. Okay. X, Shift Z. Oh, we're going unsafe, boys. Now we're cooking. Now we're cooking. If the size is less than the next power of 2 unchecked, 16. I think I also want this to return the... What is this shift? Count leading zeros. Subtract 1. If it's equal to 1, yep. Subtract 1. That becomes... Okay, this becomes a mask. Then count leading zeros. Gets us the number of zeros. Then we take max, which is all F's. And then we shift it by... Max, shift by Z. Does this work for signed? Correct 1. Okay, shift by Z. You have public dot files? No, I don't really use dot files. Pretty much everything's default. I think I want Z here as well as a ret, which is Z is the number of shift is always in bounds. What are we thinking, chat? That is the number of leading zeros, which means the number of bits minus that. Is that the power? Or is it 1 off from that? Because I think I also want to return the power of 2. CTLZ non-zero P. Okay, pow. So we're gonna get the. I guess this is LZ. I guess this is probably gonna have to be self as well. So I guess we didn't have to do that. Self max or self num bits. I think bits is what I say. Bits uncheck sub z. Right? Is that the power? Not always. Next power of 2. Less than or equal to 1. Wait, what? Wait. Wouldn't you say the next power of 2 of 1 is 2? Yeah, our state is like result. What's the allocator for? This is just a super generic allocator. No? Next power of 2 of 1 is 1? But then why does Russ say the next power of 2 of 1 is 0? Oh, because it's 1 less than. Never mind. Yeah, it's 1 less than. And then it, wait. Okay. Yeah, because this is the 1 less than model. So next power of 2 of 0 to Rust is then 1. And then for 1, it's also 1. Okay. The line 266, no, this is correct. Well, oh, now it's incorrect because this is next power of 2. Because I swapped it. When it was 1 less than, 0 was correct. Yeah. I was like, that seems off. Okay. If it's less than or equal to 1, so 0, we say 1, and 1, we say 1. Then we want to return 0 from this. Which is the... yeah, right? Is this correct here? We have like 8, 4, 1, 2, 3, 4, 8, minus 4. I think this is correct. What brand of plushies do I get? I got Squishables. Right? Leading zeros. Because when we add 1... Yeah, I think this is correct. Okay. Are we okay with this code? I think we are. In which case... let size bucket is equal to... next power of 2 unchecked. Then we're gonna do bucket size and then bucket on u minus 1 minus 3 right. But yeah, I always get the Squishables. I love them. I just got a new one. I got some marshmallows. I actually got the marshmallows like 3 years ago, and it's like the only thing that's ever been stolen as a package. So, I saw it in a store the other day, so I got it. I love them. And the marshmallows come off of a stick. They're really cool. Okay, if size is less than 8, 808. So we have size, bucket, align. Okay. If it's less than 8. Less than or equal to 8. If it's less than or equal to 8, it's less than or equal to 8, then it goes in the 8 bucket. The bucket index is 0, and the alignment for this allocation will be 8. For everything else, it will use the next power of 2, so 9 should become 16. 16 should be a bucket of 4. 4 minus 3 is 1. So that would be size 1, 16. And then for everything else, we're not going to go into a bucket. The largest that's possible is 8 megs exactly. Which minus 3 should be... Let's do it. Oh. 1620 plus 3, 23 minus 3 is 20. That's, do we need 21 buckets? Do I have an off by 1? I think so. I think we need 21 buckets. I think we need 21 buckets. Because the only buckets, 1, 2, and 4. I'm going crazy here. Eggs. Let's just print this quick. Let's go try them all out. Okay. Size buckets. Because I think this will return 20. Oh, son of a bitch. What's going on now? Uncheck sub. Oh, bits is a U size? Yeah, I don't fucking care. Do that. What? That's what I thought. Bits. No, bits is U size. Which means that this needs to be a U size. Okay. Now we're cooking. Now we're cooking, chat. Okay, this and then 23. Yes. Because we want this, so 8. Here, we'll do this. For I 0 to 32. Print I 10 and 10. Okay, and then we'll do bucket, 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 bucket. Yeah, we're just subtracting 3. And this is I probably wants type. That makes sense. Integer overflow on subtract 1 we should, nope. So 7, actually 4 should fail. No? Then is my bucket thing wrong? We'll do raw bucket. 1 shift by raw bucket. 4, 8, 16. Okay. And we should be able to go to like big number. Sure. We don't need that then. Okay, that's what I thought. I was really surprised when this wasn't getting mad at me here. Right? Because that needs to be an unchecked shift. There we go. Perfect. Fucking perfect, chat. Okay. Works. Works. Okay, so this is good. Next bar 2 unchecked. Oh yeah, but we didn't like the buckets. Right? Because we need to subtract 4 is what we need to do. Why? Oh, because 8 is shifted by 4. Wait. Wait, what? No. What? It should be 3. Right, that is equal to size, which it is. Which means I want subtract. Oh, I wasn't subtracting 3. Okay. Jesus. I was about to say, yeah, 4 shouldn't work. 5 will work. Yep. 5 will work. And yeah, 0, 0, 0, 0. So, up to 8, we just hard code that. We hard code that because it's the only one that has the special alignment. So, less than or equal to 8, we should return 8, bucket 0, and an alignment of 8. Right? For everything else, we will have a size, which comes from next bar of 2, which is this 16, which we assert correctly does match our bucket, our raw bucket count, so that is working. It is giving the power, which is what I expect. So we got the bucket, then we subtract off 3. And then that means 9 is in bucket 1 because that's 16. 17's in bucket 2. 33 is in bucket 3. Perfect. Perfect. And then this is not in a bucket. Okay. Okay, we're cooking, chat. We're cooking, chat. Get your poggers ready. Get your poggers ready. Do you know how hard it is to hype stream fucking coding? it's Get your poggers ready. We're about to align and make our allocations normalize to a bucket size. Fuck yeah! Cap 4K. 4K align. Bam! Compute the requested size and requested align. Requested align. Sanity check alignment. So you don't even have to do that. Compute the, let's do that. Just because, fuck you if you give a weird alignment. Okay, compute the actual size and alignment based on the size. And we're gonna do let size align is equal to self compute size align rec size rec align. I don't pass in a requested alignment. RSA requested alignment is less than or equal to align, cannot fulfill requested alignment with basic alloc, which uses 16-byte buckets. Get the size in the line for a requested size. That's going to give us the actual size we alloc and the actual alignment. If the requested alignment exceeds the alignment we can give it, if it wants more alignment, then we can give it. So if it wants 32 alignment and we only have 16, then tell it to go fuck itself. If the requested alignment exceeds the alignment that we can give it for that bucket, then tell it to fuck it. Hello? Hello? Basic alloc mode. Ah, interesting. Does that work? How the fuck can you do this? Is this a thing? Oh god. Kill me. Oh, yep, we want 3. Buckets. Size bucket align. Size bucket align. Have you asked the bytes if they want to be aligned though? That's what I do. I'm like, yo, do you want to be more aligned? Then I can make you aligned. I'm sorry, I can't fulfill you. Your requirements are so high. You got to go to someone who's better than me. I'm just a lowly basic alloc. I can't do that. You want more advanced alloc. Okay. Size bucket align. Size bucket align. Is that correct? Size bucket align. Size bucket align. Count ones. Zeno Bueno, thank you so much for the 52 months. The 52 month-a-roonies. You're really getting your value out of your sub. Size bucket align. Size bucket align. Size bucket align. Yeah, I think we're good now, chat. So I think what we can do is we can get rid of this and we can go cannot fulfill alignment of hello? If the requested alignment is greater. If size is equal to 8. 808. 1. If. Oh, yeah. Assert that it's less than or equal to. Yeah, that's what I had the first time. I don't know why I flipped that. Okay, so now we see we get an allocation at 8 when we, so we should be able to request an alignment of 4, and we'll get 8, and 2, and we'll get 8, and 1, and we'll get 8. Okay, very complicated. But if we were to do a 9 bytes, we'll get 16. Because that goes to the 16 bucket. And then if we say we want 32 byte alignment, this will be like, meh! And then if we do a 16 align, this will be like, woo! Okay, and then we should be able to then do an 8 afterwards. Yeah, let's go. Okay, yeah, that makes sense. It seems to work. Hey, Egoist, thank you so much for the 20 months. The 1 month streak. Too scared to sub when I don't stream. Tisk tisk. Tisk tisk. The loyalty. I remember when Twitch didn't let you have a streak unless they were in a row. That was brutal, because I think I lost like a 20 or a 30 at one point, and it was, it hurt. It hurt. It was like 1 month my credit card expired and I lost my fucking streak. It was tragic. Okay, so these buckets will go up to 8 meg. So let's do an 8 meg. Out of storage? I wonder how fast. Nice. Okay. Keep in mind, we're in MIRI. Now, let's see if we can print in here. Let's print context bucket. Bucket 20. And if we add 1, this is now, yay! Okay, so that is our indicator, go fucking Mmap, okay? So over 8 megs is our threshold for Mmap. I don't know, I pulled it out of my bum hole, so it doesn't matter too much. Next, okay. Okay. Shit, now I actually have to do the free list stuff, which I was trying to put off, chat, okay? Because I gotta read it. And then we compare exchange it with 0. No, we just set it to 0. We just store 0. Right? 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 What's this X do in Vim? If I click on this, does this close the window or all of Vim? Oh! Interesting. Okay. I was so scared. I like the X. E corp source. Atomic. So store. Yeah, doesn't atomic store give you the old value in Rust? I forget. No. Okay. There's a swap. I don't have a swap. Okay. How do they do their swap? Is there an intrinsic for it? If they don't have an intrinsic, it doesn't look like they do. Looks like they don't have that. Interesting. Then does it just use compare exchange under the hood? I guess compare exchange works, right? You can do a compare exchange and you can take I guess you no, I don't want to compare exchange. Interesting. Interesting. There's really no intrinsic? Oh, atomic exchange. Okay. Man, I was about to say, what the fuck? Tabe core source intrinsics. Atomic. Okay. Bam. 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 Exchange. The current value at dest with source and return the old value from the overwritten dest, the previous dest value. There we go. Okay. Okay. Store new into self, returning the previous value of self atomically. And what do they say? They call it swap. We take an ordering. Okay. This now returns just a T. Old, new, T. Exchange. Ord. Okay, T. New. T, ord. T, ord. Pointer, new, ord. Okay. Bam. And then temp. Are we cooking? Don't want old. New into self. So self, ref self, val, return the val. Mode, if we're constant, we can't do it. Can't do atomic set const time. If it is at runtime, emit an atomic exchange at the pointer. And we have the new value, which gives us a t. Const eval select, get the interior pointer, and then new. Bam, that should work. Then get interior pointer, deref it. Get temp, store the pointer, or store the new thing, and then return the old one. And then primitive mode, this is cannot use atomic swap. Cannot use atomic swap with primitive atomic mode. Perfect. Okay. Now 202, 202, 202, 202. Turn 6. Bing ba ba. Woo! Dude, why is chat not responding to Zano Blano? Zano Blano asked a very nice question, chat. Okay. Swap. Bam, panic, exchange. Select that, read, write, return. FPGA soft GPU? Oh, fuck yeah, that's a sick project. Are you doing Verilog or are you doing some other cursed ass modern shit? Okay. Okay, how are we gonna do this linked list? Read it. Swap it with 0. What do we want to do here? We swap it with 0. Can we do it without a compare exchange? We have to read it out. Thorn 0. Then someone else could free. And we need to compare exchange. Hmm. 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 What do we want here? Read. Read. Depending should be easy. Yep. What do we want to do this linked list? Hmm. Tibia was my first time. Oh, hell yeah. Same. That's what this computer's named after. The game. Man. I don't think I can do a linked list without compare exchange. Which is tragic? Exchange with a 0? Exchange with a 0. That gives us that. For me, it was RuneScape. Yeah, I think RuneScape was just. It's hard to say if it was a better game. I mean, Tibia was earlier, so it's hard to compare. I think they're different enough games, but at the time, I do think RuneScape was way more popular. Tibia never was a super popular game. Even during its peak, it wasn't that popular. I think RuneScape was more popular. I don't know how I want to do this linked list. Wasn't allowed to play RuneScape as a kid. That's probably a good thing. Man, I'm really struggling to come up with a clever way of doing a free list. I really want to avoid the compare exchange. Hmm. So I can see an interesting way. It doesn't get rid of the compare exchange, but you could have like a like allocate ID, kind of like a thread ID, but not exactly a thread ID, where you have like separate free lists for each user of the allocator, and it basically means you'll have no contention with your free list until it grows to a large enough size. Then you pay alloc to put it in a global free list, is kind of what I'm thinking. Where it's like you maintain a free list of like 32 entries or so. You do that per thread. You have to do it with atomics because it has to be thread safe. But because atomics are fairly fast single-threaded. I think atomics are still like probably a 4x slowdown to non-atomics. But as long as you don't have contention, they're really not that expensive. Because ultimately, it does have to be thread safe. If I want to share like a table, interesting. Do we like that? Do we like that design? Well, now this is starting to become a more advanced allocator. If we go that route. Why does it have atomic types instead of functions and macros that work on the correct non-atomic types? Because atomics just require more information. You can't really just make a non-atomic thing into atomics. Atomics require more explicit information like ordering, and thus you can't really conflate the two. No, I think that's okay. I think it's okay with this. Okay. So the intent is that we make this basic allocator. And the goal would be that every thread makes its own basic alloc. Could we do that? Could we make it so you can intermix them, but basically the intent is that threads allocate out of their own basic alloc. Threads are effectively never thrashing their free list, so it's effectively, you're paying like a 3x cost for the atomic, which is kind of below the cost of just allocations in general. So you have an atomic, but your data structure is always in your cache, and thus you're not actually doing any, you don't have to do any broadcasts, right? You always have this in your exclusive cache. And then you end up mixing these into a data structure. Let's say you have a bunch of allocators contributing to a large data structure. That large data structure can then be freed by one thread, and it kind of just naturally distributes the load to different cache lines. I think that's actually kind of cool. You kind of get like a memory interleaving effect by nature of threads having their own allocators. As long as you're constructing, you're doing like insert only. If you're doing insert only, you will only ever be using your thread's allocator, because you'll literally be using the allocator, the basic alloc you allocated, like on the stack in your hot loop. Right? You allocate your allocator and then you parse your file into like a structured representation, right? So what I want is that you make this allocator, you parse your shit, and I want it so that threads can be parsing in parallel into like unified data structures, but you're only ever going to be allocating out of your thread, which means this basic alloc is thread exclusive during almost the entire construction. So you're like allocating a shit ton. Then when it comes to teardown time, you'll get torn down probably by one thread. And that's okay because all of the allocators will then be exclusive to that one thread during teardown. So the only situation where you really would have, like, clashing on the alloc is if you allocate some shit, you pass that shit to another thread, who then uses that existing, like, vector and grows it, which is effectively two separate threads contributing to the same thing. Is like the only case where you'd have contention over the free list, which means I think the compare exchange just isn't very expensive because you just fundamentally shouldn't design threaded shit like that. Right. Like, I think it's actually not... I think it's not as scary as I think to have effectively a lock on the free list, because you kind of need a lock on the free list. If you let other threads free on your behalf, then you pretty much need a lock. And luckily, I can do that, and we can put it in cell mode, so if you don't plan on sharing the allocations to another thread, then you don't need that cost anyways, and it's just a ref cell, right? So we added support for atomic pointers, but we're actually not even going to use the atomic pointer, because we're just going to do a mutex of a pointer. And by mutex, I mean whatever I call it. What do I call my thing? Locked. Okay. desync, sync, in sync mode. Yep. Yep. So what I should be able to do is do locked mode. Right? And now we actually have a spin lock around that. Nice. And that uses a mode switch, which is good. Nice. Yeah, it's a shame that I don't need mutable, or I don't need the pointer atomics, because we spent time doing that. But I'm sure at some point I'll use atomic pointers. Okay, so now we do a locked, lock new. Yeah, lock new. Okay, I'm starting to feel it, Mr. Krabs. Yeah, let's go! Let's go! Okay, so our code builds. So now we can make a linked list. Or a linked anything, basically. Really easy. We could make a linked list of arrays, which is usually a lot faster because you're not thrashing as many cache lines. But let's just start with the basics for now, okay? So, check if we have a free entry in the free list. So we're going to get a free list. We could also probably put these on their own cache lines. So even if there's contention, if they're on different sizes, then in theory there isn't contention, but that seems unlikely. Okay. Self dot if bucket is not 0, directly mmap. Special case for large allocations. See ya, Zano Bueno. Else self.freelist.get unchecked bucket. Okay, get unchecked. Then we're gonna do fl dot lock. Right, so then we have exclusive access. Let's fucking go. You plan on streaming more often? I don't know. I'd like to, but I don't know. This is like a fun stream project, but sometimes I don't have any fun projects for streaming. Okay. If lock is null, right? Nice. If that is null, if this is not null, there was a free entry, reuse it, otherwise fall through, right? So this will end up returning early, and this is going to then do let ret is equal to lock, right? So read the pointed to value. And this is mute u8. Then we're going to do let next is equal to mute usa. This is actually mute u8, which is a ret as mute u8 deref. loc is equal to next, return rsokret. Right, so read the, so get the value, get the entry. We know that the entry exists. So then we deref the entry, and the entry points to the next thing. So we store the metadata in band. This is colon. So then we deref that. We store the next back into the list. And then, yeah, basically this is just a pop. It's a linked list pop. Okay. Now, bam. Okay, so then when we go to free, I'm gonna do the same thing. Determine the free list bucket. Whoop. Old mute u8 is equal to the old is equal to lock. If bucket is not 0, loop. Okay. Okay. Get the free list if lock it. Get the old pointer, which might be null. Then we're gonna take the pointer as mute u8. Write old. And then we're gonna do lock is equal to pointer. Pointer to the free list. Okay. Size, bucket, and alignment. Alignment doesn't matter here. So we're gonna look up the size. That's gonna give us the size and the bucket. We look up the bucket in the free list. We lock it down, which is an atomic spin lock or a ref cell. So we lock that down. We read it, which gives us the old thing, which is probably null, or could be null. Then we write it in, which is basically nulling out that part of the freed pointer, and then we link that back up. So this should be now correct, in my opinion, such that we should do a drop on alloc. Do I have drop? Yes. If we drop that, we should pick it right back up, and we don't. Because we don't call dealloc, because we're not doing drop yet. Okay. Dot dealloc. Elk, and that was 4 bytes. And this is unsafe. Hey, there we go. Okay. But if we alloc again, we'll get 18 because we got a new pointer, and then I should be able to free that. And we just get it again. Okay? And if I do a large one, that's in a different, well, that's the same bucket. 9 will be a different bucket. That will be different. What do you think about the people that hate on us and praise C? I don't know. I don't know. It's just, they probably just don't understand the value of Rust. Which I would say they're probably wrong. I mean, don't get me wrong, Rust has many flaws and it's annoying and blah blah blah, but it's definitely way better than C. I feel like that's just kind of how it is. At least if you care about like doing low-level performance stuff, IMO. If you want to do high-level shit, then you shouldn't even be doing Rust or C. Just use like fucking Go or Java or C#, fucking Python. Who cares? That's kind of my view. Okay, so then next, this should be pretty cheap. So we lock that down and we write that in. Okay. And then, yup. Okay. Then, yeah, let's do the big Mmap case. Let's actually say 4096, because that's more accurate here. Size. And then we're not in a bucket. What is RSC? It's like the question mark, basically. It's just checking for an error. Okay, so then we should be able to do a direct mmap here. This is just this. Be able to allocate directly with mmap, so then this is going to be size. Mmap, don't care where, size bytes, read, write, private, anonymous, no file, bam, cast, the result if it's successful to a pointer to U8, and return that. Okay. So if that's not 0, then we map, mmap, read, write, bam. Okay. Damn, does MIRI not tell us about leaks if it's from Mmap? It's kind of tragic. Forcing one to use cursor? I don't know what cursor is, so I have no idea. Oh, like making sure you're actually like at your computer? A VS Code fork by an AI company? Oh, fuck that, yeah. Size, read, write. Bucket. Okay, so right now we have memory leaks, right? Because we don't munmap that, and we don't munmap our pool. Yeah, it's time to break up the monopolies again, boys. Companies have gotten too big. People are just cogs. People have no meaning. They're just monkeys on keyboards. Hierarchies have gotten too tall. Next. Okay. So let's get our Mmap going with the big boy. Okay, perfect. There's our loop. Yep. Obviously, we got a different allocation, which is good. Man, I wish Rust told me if I had Mmap leaks. I kind of like being able to rely on MIRI to tell me if I have mem leaks. Okay. How does MIRI hint that allocations occurred? I don't think you can hint. I think it just naturally works through how it hooks externs. I don't even know if it does it on malloc. I know they hook malloc, but I don't even know if they do that. They might only do leak detection on Rust allocations. Yeah, there is an Mmap shim. There's shims for like a lot of syscalls. Well, libc calls. But yeah, I mean, it wouldn't even be aware of my allocations anyways. It would be nice if there was a hint. If there isn't one, that would be kind of a nice thing to add to it. Because it has support for, like, aligned alloc. And it does aligned alloc in shims. It's para 2. Alloc pointer? I think if I used aligned alloc, Rust would know, or MIRI would know. We'll try that in a minute. Actually, fuck it, let's try it now. Corp source. Syscall. Yeah, this is gonna be weird because it's like a slightly different way of handling it. But yeah, because it calls this allocate pointer MIRI memory kind C. This is may leak for MIRI memory kind. Look at this. Look at this. Fuck. May leak. So Mmap is allowed to leak. So Rust, MIRI, C, WinHeap, WinLocal, and Runtime are not allowed to leak, but Mmap is allowed to leak. So I think what I could do is I could just have my Mmap call a fucking different one, where I can just do, oh, what's MIRI alloc, actually? Wait. What is this? All tests? Because, yeah, there is Rust alloc, but then there's MIRI alloc. What would be cool is if there was a hint, like an allocation hint. MIRI bare metal heap. Last team. MIRI memory kind. Init local. Yeah, because Rust does this, allocator, allocate pointer. Check Rust alloc request. Alloc memo line. Whoa, what's this? Oh, this is allocate aligned memory. Because I'd really like to keep it stored how it is stored. But I think we could just do aligned alloc. And aligned alloc would give us a C alloc. Or we could do malloc. It doesn't fucking matter. Just malloc is fine. Actually, I'd probably do aligned alloc just because it's a little bit more obvious exactly what it's doing. So power it 2, otherwise null. Because, yeah, if we translate our mmap to an aligned alloc, then I think we will get leak checking, which would allow us to check our implementation, and then we can have it do the allocations. So in here, we can do a wrapper. Mmap. Yeah. Let's do this. Chat. Get your poggers up. Get your poggers up. You think my poggers are ever down? Yeah, I do. I do. And that's kind of cringe, to be honest. Not gonna lie, kind of cringe. That your poggers can be down sometimes. Raw alloc capacity. Okay, bam, goes through there. Bam, bam. Thank you, ma'am. Perfect. Then we're doing the same thing here. Mm-hmm. Okay. Oh, shit. Mm, Mm-hmm. Can you do that? Can you say that it's self? Is that a thing? Is that a thing? No way that's how that works. Fuck. Fuck. How do we do this? How do we do this? Bup. Mm-hmm. Ugh, but now I have to do mode as well. Oh my fucking god. Um. Oh. Wait a tick. I can just do this, right? Wait. Let's just move it out, because it doesn't have to be in here. That makes our life a lot easier. X fucking D. Fucking easy, chat. Easy. And then this is size. Allocate size. Beautiful. Beautiful. And CFN. Good. Okay. So then we can do configure for MIRI on safe. Oh fuck yeah, dude. Fuck yeah. Extern Rust. FN MIRI. Args. I think it's, yeah, just U sizes. Okay. MIRI alloc. This is unsafe. Size 4096 is the alignment today. Actually, we'll think about this. We'll think about it. Else RST failed to allocate memory with MIRI alloc. Unsafe. Dick. Okay. Okay. Const eval select, size align, CFN and CFN. Right? Right? Size align. Size align, size align. Size align. Size align. Align. Okay. Assert that the alignment is less than or equal to 4K. Cannot do greater than 4 gigabyte alignment with Mmap. Okay, assert that the alignment is less than or equal to 4K. Then we have Mmap for size. So we no longer care about the alignment. Size, that looks good. Okay, and here we do const allocate size align. Size align, size align, size align, size align, size align. If it is not null, then it's good. Otherwise, we failed with MIRI alloc. I'm just gonna check this one as well. I don't know if it can fail, but I'm just scared. If it's not null, we got an allocation. So size align, size align. Okay. Bam. I think const allocate is unsafe. I think. 109, raw alloc. 109. So this gets actually replaced with raw alloc capacity 4096. I guess technically 16-byte alignment is what I absolutely require for this. Right? So we only actually expect 16. So now we do raw alloc of capacity bytes with 16-byte alignment. So the base is 16-byte aligned, which means the index can be used to tell us about the alignment of entries. Okay, raw alloc is going to go up here. We're going to do raw alloc assert alignment is less than or equal to 4K. Assert that the alignment count ones is equal to 1. Alignment must be a power of 2. So 1 bit is set. And the alignment is less than or equal to 4K. And then this one down here is just make sure that the alignment is a power of 2. Does the size have to be a power of 2? Align must be a power of 2. Okay, yep. So assert that the alignment is a power of 2. Bam. Okay, and then we just pass through the size and align directly. Good. Good. Good, good, good. Okay. Two arguments, one is supplied. 129. Raw alloc. This is for, that's a page alignment. Okay. I guess we'll just say 16 for that one too. Fuck. Didn't mean to close that. Raw alloc size 16. The 16-byte alignment for that. And count ones, less than equal, count ones. Bam. 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 What? Fair. Okay, so actually this is unsafe. Yeah, I was about to say. Okay, perfect. So now we're going through MIRI alloc, which means that we should see a leak now. Right? So if we get rid of our large free, which spins right now, this should print, yes, we got a leak. We got leaks. Hell yeah. Okay, so we got leak detection. Okay. 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 Now we just have to make free, raw free. Directly allocate memory using either Mmap, runtime, real system, or MIRI, runtime MIRI, or Const allocate, const time. Oh, I guess, yeah. This CFG MIRI, we actually have to change this around. That CFG needs to actually happen here. Bam. Okay. Then get rid of that, this. Then we go bam, bam. Then we go whoop, bow, and swoop, bop. Okay. 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 I guess we're always asserting power of 2. Makes sense. Okay. Alignment must be a power of 2. Then we have the constant version, which uses const allocate with the size null line. If that's null, if it's not null, allocation, otherwise we failed. Then at runtime, if it's not MIRI, then the alignment must be less than or equal to 4K, and then we just poop it out with Mmap. We allocate the size, read write, private, anonymous. Bam. And if we're in MIRI, then we do a MIRI alloc for size and align. Perfect. So that should cover all 3 modes. And then that means that we create a raw backing storage that is 16-byte aligned. Beautiful. And now we have leaks. And if we get rid of the 16 alloc, we should have a leak still, because the actual pool itself is also leaking, which is good. Beautiful, which is the size of the heap. So if we make this 1 meg, we'll now see this is the 1 meg, and if we put in the 16 meg, we probably will see both. Yep, there's one, there's the other. Both of them are 16-byte aligned. Perfect. Okay. So allocate the actual heap for capacity with 16-byte alignment requirement, and then directly mmap if we're larger than our largest bucket size. Directly do our allocation, which is also going to be strictly 16-byte aligned with MIRI. Okay. Okay. Next, we need to do raw free. Yeah, we just need to do raw free, which is the same fucking thing. Const deallocate. Raw dealloc. Okay. Pub unsafe. Pointer. Mute u8. You know what? I think this one's just gonna always return success. Must be a valid pointer in pointer, size, and align combo from what was used for raw alloc. Okay. This is const deallocate pointer size align. Okay, bam. Okay. And this is going to be a Mmap. Pointer. Okay, no return value. Can't do that. We're just going to discard the result of a Mmap for size. Right? Then this is probably dealloc, I imagine. I don't actually know what that is. Let's see. Dealloc, I imagine. Pointer. Pointer. So we pass in the pointer size and a line. Pointer size align. Pointer size align. Just const dealloc that. Here we do Mmap of, not null, but pointer. To actually free it, we discard the alignment in that case. And then in MIRI's case, we do a dealloc, I imagine, of all three. Yeah. Pointer size align. Pointer, usize, usize. Okay. Perfect. Now, we should be able to then dealloc. Which is, this is going to be raw. So we did raw alloc up here. Raw alloc, which takes size in 16. This is going to take size and 16. And the pointer. Okay, and then we'll just do return. If the bucket is the Mmap one, then raw dealloc pointer size 16, which is raw alloc. Actually, this is the requested size. We want it to be very tight. So size is going to be bucket aligned, but when we do raw allocations, we actually want to use the exact requested size to the byte. So if something's allocating 1 byte, we want to make sure we only get 1 byte. So if this is like 1 meg plus 1 byte, we'd get 1 meg plus 1 byte as the actual allocation. Now that's going to be page aligned on with Mmap, but at Const time and at MIRI time, that will be strict exactly to the byte. That also means down here, it's the same thing. We're going to have a requested size. We're going to determine our size and bucket, and then we're actually going to use the requested size to dealloc, which then matches, because this does requested size 16, this is requested size 16. With the pointer, that should be correctly freeing. Now, we're going to still have a leak for both because we have to explicitly call free right now for here. Now we're leaking just the 1, but we should be able to add 1 to this. If we do this, we should have like a, yes, undefined. Yep, trying to free with the wrong size, and if we add 1 here, this is now okay, which is good. It means that 1 byte is correctly flowing through both the alloc and the dealloc. And now all we have to do is implement drop for basic alloc. Drop. Pub fn drop, mute self, unsafe. This is then going to be raw dealloc. Then we have the capacity in here. So we're going to do raw dealloc self.storage, self.capacity 16. Right? Bam. Storage capacity 16. Let's go, chat. Yep. $219 size is unused. Yeah, that makes sense. Okay, now this will fail to, or there'll be a warning, I think, or something. 101. Yep. Yes. Cast into a C void pointer. And yeah, that the align is unused in this case. So let blah is align. Woo! No warnings, no errors. Perfect. So now what this means is that MIRI is kind of making sure that our actual heap usage is correct. And we're also using MIRI dealloc and MIRI alloc, which is giving us alignment checking, which we're not getting, or it's getting us leak detection, which we don't get with Mmap directly. So basically, if we're in MIRI, we're gonna use MIRI alloc, which gives us that slightly stricter heap, which is good. So we null check both of those. This looks good. Size align, size align. Align must be less than or equal to 4K. Size align. And align must be a power of 2, which is required for both const allocate and MIRI alloc. I think both require that. Okay. Const deallocate, get size align, new, so we do a raw alloc of capacity, so that will be exactly capacity bytes. So we would get 1 byte of storage, for example, with MIRI. Yep, that would come through, and we would get 1 byte of storage with 16-byte alignment, which is good. In use is 0. Capacity. We have our free lists. Deallocate the heap, which is, yep, that drops the whole heap. Tell me the VOD will be uploaded? Yeah, I can upload it. Pub const unsave fn, we only missed the async, yeah. Okay. So, this has allowed me to verify that I don't have leaks, right? My implementation does not have leaks. But what I actually want to do is, so this lets me test the free list. Here's kind of the problem with MIRI. Like, what I want to do is probably test this allocator where MIRI is enabled the way it is now, where MIRI is backing the allocations that are backed by Mmap, right? But in the future, once I kind of prove out this allocator to be stable and like the free list to not have use after freeze, then what I actually will want to do is change it to, you know what? I actually could just have all allocations. I think what I could do is, make it where allocations can be freed to the free list. It's tricky. It's tricky. It's tricky. Because I want MIRI to like be completely aware of what the heap is doing, but that also doesn't let me test my heap with MIRI itself, because we'd be bypassing the heap. So I like this right now. Right? We use raw alloc. We use dealloc uses raw dealloc for the Mmap case. And basically, MIRI wouldn't be able to provide us with leak detection right now. I could make it where every alloc here, instead of bump allocating, I could return what I could potentially do is make it so I never bump alloc, and instead I just return a fresh new alloc from MIRI at all times. That would then at least test the free list logic, which is what I'm more worried about. It would give me free list logic, and it would give me like per object free or per object what am I trying to say? I don't like that. I don't like that. For now, this is what I actually want. I actually want MIRI to be testing my heap implementation. And I should be able to do like a 0-byte heap should be fine, right? Ooh, allocation with size 0. Uh-oh. 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 Spaghetti-o. MIRI alloc doesn't like size 0 allocs. Okay. Okay. Bam. Bam. Out of storage. And I should be able to do 9. And now it's failing on... That fails because it allocates actually 16. This should work. Yep, we got 1 allocation. Perfect. Okay. So there we go. I think we have an allocator, right? Is that everything? I think that's everything. And it should be all MIRI aware. Well, really the only thing MIRI is tracking is allocations larger than 8 meg and the actual heap itself, which obviously my fucking drop handler is freeing the heap correctly. So that's easy. Yeah, I really would want to be able to like hint to MIRI. That's what I want. What I really want is to be able to tell MIRI, hey, I have freed an allocation, but I haven't actually freed it. And I bet that would be pretty easy to plumb through. My guess. Because you're just doing an allocation without creating stuff. But maybe that would cause problems with the base allocation. Maybe you'd have to handle like fragmenting the old allocation or something. But that would be really nice. Oh wait, what's this? What's MIRI track alloc? What's this? What's MIRI track alloc? The fuck is this? God damn it. Is this exactly what I want? But how would I free it? MIRI right to stand it out. Huh. Interesting. I didn't know that existed. I should use that. This is really cool. There's a lot of stuff. I should do exit. Oh, this is cool. Yeah, I don't know why I'm using syscall shims. I should, well, I guess syscall shims allow me to test a deeper amount of my stack. If that makes sense. Because then I'm actually going through my real syscall handlers and stuff, which in theory could have a bug. Okay, what does MIRI track alloc? Size? Where's size? Info, size? Tracked alloc IDs. Get alloc, read pointer. Static root? Do target path. Frame name. Yeah, I don't know what track alloc is doing. You give it a pointer? Tracked alloc IDs? That's probably something else, I guess, maybe. What's this? Add the allocation. Yeah. Yeah. TLDR, there isn't any. I don't think. I wouldn't be surprised if they would accept a PR for that. Because I feel like that's pretty reasonable. You borrow parts of memory, you give out a pointer to those who ask for allocations. So I think borrowing rules already apply to this model. It just wouldn't be able to detect. Would it be able to detect use after free? It might be able to. Okay. Yeah, it can't detect multiple frees of the same pointer. Let's see if it catches this. Keeping two allocations of the same pointer alive? Yeah, it didn't care about that. Actually, if I do this. Okay. Yes. Yes. So yep, and a retag. Perfect. So that can I literally just make a mutable reference to it? Or is it really caring? Because then I feel like that could cause issues with actual uses of it. In intermediate slice, return a pointer to slice. I could probably do that. This would then be a pointer to slice. You want a slice. Before you return a pointer, create a slice? You think? Think that would work? That still I don't think would prevent double freeze? Would it? Maybe you would see the double free as a right to well, the problem is I'm storing metadata in unused allocations. Hey, S'mores, you up from your nap? Did you have a nice nap? Yeah. I'm not sure yet, chat. Okay. All right, let's see how fast it is in a super hot loop. Let's see how fast it is in a super hot loop. 8. Oh yeah, will this complain? Yes, cannot fulfill alloc. Perfect. Okay. I guess it can optimize this out. Can it? I don't think it can. Yeah, it can't optimize this out. That's what I thought. Because it can return an error. LLVM is not capable of proving this. It's too deep at this point. You pretty much have to, you can't really use pointers if you want to have this. But yeah, that looks pretty good. What was that, 1 billion? 1 billion allocs in, we're doing 5 billion allocs a second? That's really good. Well, let's see what we got. That's really good. Fuck is my code? God damn it. Fucking prints, man. Ugh, still have fucking prints. Tab, code, size, check, cargo, toml, features, sensor errors. There we go. Now it's 245 bytes. Now this might be optimized out. I would suspect this is now optimized out. Maybe? I don't think it's optimized out. Maybe? E4, syscall, E4. I think it is now. If I were to add the elapsed in, what do we get? Yeah, now it's optimized out. Okay. Okay. This should not be optimized out anymore. You have black box? No. There we go. Now it's not optimized out. Okay, so we can comment that out, and then we can look at the code gen. I mean, it might be optimized out in that it's like removing all the code that's doing anything. Because the loop has to be in here now. Where's the nop? Here it is. Nop, deck. Yeah. Okay, yeah, it is optimized out. That is okay. Alloc.write volatile 5. I think I have write volatile. Fucking dick. Do I not have it? Oh, I do. I just haven't made a wrapper for him yet. Okay, now it's slow as shit. Wait. It's just doing the store in a loop. That's good. That's what I want. Oh, you know how we can fix this? Here we go. You want to see how we can fix it, chat? You should be able to do this. Can it remove? Can it remove those? Oh, sorry, cell. Atomic. About to say. There. What? Did I call it sync now? I can't remember. I did. Okay, now we're cooking. Now we've actually got, we should have atomic instructions. Yep, there's our compare exchange. So there's a lock, we have a spin lock. Good. This has to have the actual locks. So this is like absolute worst case scenario for perf. And this is effectively what would happen if you had this shared between things. Now it's gonna be slow as shit. Okay, it's not dog slow. It's not dog slow. It's like 100 millisecond, which, yeah, is probably about as fast as you're gonna get for, that's probably about as fast as you're gonna possibly get for a thread-safe allocator, right? Obviously, it's gonna get much slower if many threads are using it, but the goal would be that each thread would make an allocator, and it's really never going, it's like not intended that it's ever used across threads. Like, it would be very rare that another thread would cause an allocation with your allocator. Only if you're like growing a vector or freeing it, but if you're freeing it, it's probably one thread tearing down everything, in which case it's kind of single-threaded again. Like, another thread effectively takes ownership. From the perspective of cache locality, only one thread is really going to be using the lock at a time, which means it's going to be quite cheap. But if you don't want to use threads, like if you're never going to share it, you're never going to share anything allocated by this sync or send, then use fucking cell mode and it'll be basically optimized out. Like, it will be nearly free. It'll only ever exist, like, across boundaries that the compiler can't inline past. But if the compiler can, like, see your entire code shape, it'll just get deleted. Right? And that's why I really like having this switchable cell versus atomic mode, because it's all the same code. It's one code base I have to, like, test, prove, make sure works. And all I do is I just switch that. I switch that, and it goes from an atomic version to a ref cell version, right? One of them basically uses a mutex, and the other one uses a ref cell for the free list. The actual bump allocator is just a fetch add, which is a cell, right? So allocs use a cell, frees use a ref cell, or an atomic add, or a mutex. I don't have box, no. But yeah, now I can tie this into my vec. All I'll do is, I'll do the same thing Rust does, where vecs will have a generic t, the t implements allocator, and then when I allocate, I'll pass in a reference to a basic alloc, right? So that reference will have to be something that can survive threads if I need to share between, but that should be really easy, right? Or I could do like an arc, right? Because this is sync if you use sync mode. If you use cell mode, it's not sync, which is fine. You can only use it for your thread, which my plan would be that for single-threaded stuff, I would use probably a ref to the allocator in the vector. And then across threads, I would probably still use a reference, but I would initially pass that via an arc, right? Yeah, I have vec. So I think I'm pretty much only ever going to use allocator by reference. Because I don't think there's really a need to use an arc, because I can share the reference between threads in another way, in my opinion, right? Like, I don't see where I would need to clone. Basically, the reason I need to use RC or ARC for the actual allocator on Vec is if I wanted to be able to clone the allocator in Vec. But I mean, I can do that with a ref. I don't know. My view is like, I think it's a lot cleaner to have the ref, like the strong lifetime associating the allocator effectively with the vector. But I don't know, maybe I'll end up hating that, but I don't think so. I don't know, the way that I do allocators, I feel like I can always point to where things came from. Which actually, eventually I will probably replace this with an allocator that strictly requires, through invariant lifetimes, that they match, right? Then it's going to be actually allocations must come from that pool, which then allows me to do even more optimizations. Because then I don't have to use pointers, then I can use indices into it, and I could use 32-bit indices. I don't have to use full width pointers. I can then like free everything at the same time. I can move things, like I can move the whole heap. Like that's kind of my plan long term, but that's Allocator, right? And Allocator is like a week project, not a one-day project, and I kind of wanted a one-day project, and then I'll do Allocator in the future. But Allocator is going to be a little tricky in core, but also a little easier, because Allocator did genericize, or had a different, like, two implementations. It had one that was sync and one that was not sync, and now in core I can do one implementation and get both, which is going to be really cool. And the goal of Allocator is that I can have nested allocators, where like each allocator must be fully contained inside of its parent. So effectively, like, you can have a global allocator that is thread safe, that then gives out a large chunk that is then used as a thread local allocator, and everything is known to share the same indices, and if you get a mutable reference to the parent allocator, aka you own everything, you can safely like mem copy it to a different location, and the heap is still valid, right? Because everything is done by index, not by pointer, but you cannot contaminate the pool. You can only ever store things that refer to things inside or nested below it, if that makes sense. Or more specifically, the children, like the smaller pools inside of the big pool, can refer to objects in the big pool, but the big pool cannot refer to things on its way down. But you can do like the whole thing in the Rust type system. It's really cool. I like it. My plan is to hopefully move basically the entire dynamic allocation system of core to that model, which is a little harder to use, and you'll have to use like all the closures and shit. And unfortunately, closures really suck right now at const time, but you can make them work with a macro, because you can manually create the context that you pass into the closure, and then they work, and it's really toxic, but it works. So anyways, I think I'm going to wrap that up for now. I got to play with s'mores. I've ignored them for 6 hours, and I feel bad. So I'm going to play with s'mores, and then I'm just going to slap this onto vectors, but I think this should just work. Should just work as is. I don't know. I mean, we haven't really, like, tested it to make sure there aren't bugs, but I'll probably write something that just randomly does some allocs and frees and shit, and tries to find bugs, and then we'll wrap it in vector and then try it again. So, what are you going to use the allocator for? Just any dynamic allocations. So, just vectors. Vectors are the only source of dynamic allocations in my entire core. So, by making vectors use this, everything else, all my maps, all of those will inherently use this as well. So, all right, well, I'm happy with that. I will see you guys around some other time.